Okay. Alrighty, dudes. Let's see what we got here. Yeah, fellas, there really ain't much today, to be honest with you. Yeah, it's kind of slow, so I mean, either we can chill and talk about something else, or or just a particular spaceflight topic or something. Maybe we'll do story time. I don't know. Teach people about stages or whatever. Usually when we have, not a high news cycle, I use space news to teach people about different, like, rocket history or whatnot. Let's talk about rockets. All right. Let's talk about cursed rockets again. No. All right. Let me just pop into the feed here, and we'll see. So anyway, welcome to Space News. Let's see what we got. So we actually got more footage of launcher. How many floors is 120 meters? 40 stories. I may or may not have a suggestion. All right, Meeps. EJ knows what I'm going to suggest. We could always watch that too. Yeah. Oh, there. Oh. All right, we got a ton of links. Okay. OLM hold down clamps. Also, Star Factory's name. I got your links already, Creeper. Let's see. Oh, never mind. No. Yeah, okay. I got some stuff to talk. Yeah, those pictures though from Tom. Damn. All right. Okay. Yep. All right. Let's jump in. So, okay. Perseverance video. Oh, maybe we can start with that. Oh, the solar eclipse. Okay, yeah, no, I've showed that video before. Okay, cool. So let's start here. Tom McCool it looks like some press got to look around on different pads here. Tom McCool, who's he's a photographer, combat correspondent, took pictures here. That's Relativity's pad at Complex 16. Look at that. That thing's getting ready to go, man. That looks pretty freaking finished. It was family day at the Cape, apparently. I'll think about it, serious. Have you talked about the NASA 99% light speed engine concept? Is that the negative mass density one, Mycon? Hello from the Elder Planetarium. Hey, Dr. Death. That's cool. All right, so check that out. That's for the, Terran 1 rocket. The first, fully 3D printed rocket from, back to front, except for, fittings and stuff. That's what Relativity's working on. Relativity works on this pad. Here, let's go. Let's pop into Google Earth. I'll show you where this is. So, I guess, everybody got to, tour around on the Cape and stuff and see all the pads and whatnot. So, we got some really cool pictures from different pads. Yeah, Thomas, I'll show that in a second. That pad is LC16, which is 11, 12, 13, 14. And then there's, 16, 18, 19, and 20? I think it's this one. There's so many old launch pads. Okay, so these pads right here, that are all in a row, are called, Missile Row. These were all test launch pads for ICBMs in the late 50s, early 60s. And basically, it's kind of funny because everything kind of north of Missile Row was designed for human spaceflight, if you really want a good rule of thumb. Believe it or not, human space flight and like orbital launches, like i.e., I shouldn't just say human space flight. This is orbital space flight. This is ICBMs down here. Like all of this, all these pads down here are for ICBMs. Everything up here is like the cool stuff, the stuff that we like. So there's like 34, 36B, 36A, 40, 41, 39A, and 39B. These are all, this is the good stuff over here. But, you know, these pads fell out of favor after, you know, we did all the missile testing that we needed. And then now commercial companies are picking these pads up, which is actually really neat. Here, we should be able to get an updated view here. Yeah, see? Check it out. Some of these pads are still abandoned. The flame buckets on these pads are still here. These kind of like this one that has the raceway that goes out, or not raceway, the road that goes out here and then it curves around. These are ex-Titan pads, Titan 1 and Titan 2. So 1, 2, 3, and 4 are those are all Titan pads. I think I found the one that Relativity is working on. So that picture was taken right here looking this way, if I'm seeing that correctly.
Hey, Biggie.
You leaving?
I'm leaving.
All right.
I love you.
Love you too. Happy birthday.
Thank you.
Be safe, okay?
I will. I'm walking.
I know. People drive like Dookie. Just be safe.
This is true. I will be safe.
All right. Keep in touch with me, okay?
All right.
Can you do me one favor before you leave? Can you go get one of the battery packs and a charging cable from the kitchen? Because my phone is dead from watching Formula One.
Okay.
I love you.
I love you too.
Happy birthday.
Thank you. And thank you, chat, for your birthday wishes.
Discovery, go and throttle up.
Thanks, guys. It's your birthday and not hanging? B-Money, we're hanging tomorrow and Monday. Hey, Ordon, 28-month resub. Yeah, on the weekend, we talked about this, so. Not you and I, me and her. You guys don't have anything to do with that. Someone on YouTube posted a short vid from Family Day. Mute the video first. You're awesome.
I try.
I love you.
I love you too.
All right. Chat says happy birthday.
Thank you, chat. You're a lovely chat. Mwah.
All right. Have fun, okay?
Yeah, I will. Love you, baby.
Love you. See ya. Okay. So, that's where this shot is taken. You see the two stacks of tanks right there. See? 1 and 2. And, yeah, right there. Yeah, so that's LC-16. So, let's see. So, there's 11, 12, 13, 14. So that one's got to be 15, 16, 18, and 20, I think. Actually, that one might be 20. It's crazy because other companies have purchased these pads as well. Like, if you notice, like, some of these pads still have some stuff going on. Actually, it looks like this pad was converted for other use. There's a twin pad complex. See that one? I forget which one this is, though. She's really nice to chat. She's a nice lady. And then there's Complex 34. Let's be real. 34 is not launching anything ever again. But there's Complex 34. Yeah. Yeah, that's the one where Apollo 1 was. The top one is Slick 20. Firefly will use that. 20 was also used for a lot of random things. Yeah, these look like missile testing right here. But that one is abandoned in place. But it's interesting because each pad, while being the same, has slight differences. This has a percolation pond, depending on what they were testing with Titan at the time. Like, see that one has the pond. This one doesn't. That Relativities has the pond as well, and then that one doesn't either. That one's probably in the worst condition. Man, that one's really messed up. I wonder when the last time anybody was down there was. And then right here, this one is Complex 14. Complex 14 will never get used to launch anything again. Well, actually, we don't know that for sure, but I'm pretty dang sure. The reason why is Complex 14 was Mercury Atlas. Godspeed, John Glenn. First American in orbit launched from here. First American in space launched from LC-5, which is over here. See? LC-5. Check phone. Oh. Huh. Huh. Well, that's just parked outside the apartment complex. Well, that's pretty neat. Yeah. Yeah, that's a 69 GTO. Yeah, 69 GTO Judge. Metallic mint green. Seriously, it's metallic mint green. Just like my cousin Vinny's, same paint color. With a white vinyl top. Yep, okay. Yep. Yep. It's metallic mint green, just like my cousin Vinny. Anyway. So, let's see. What other pictures does Tom have? So that one's from Relativity, which is really cool. It looks like this thing's almost completed. It's almost ready to go. So 5 was... LC-14 was the first orbital flight. John Glenn, Mercury Atlas. Mercury Redstone was Alan Shepard from LC-5. He basically did a New Shepard up and down, which is why New Shepard is named after Alan Shepard, because the Mercury Redstone flight that Alan Shepard flew is very similar to New Shepard's trajectory, you know, minus the coming back down and landing part. Meeps might know something about that, though. But 2 what? 2 utes. What is a ute? Check the seat for a Colt 45. It was a 357 Magnum. All right. So, let's see what else Tom has. Oh! That's the new Glenn Pathfinder. Hang on. Gotta blow out the mouse. That'll fix it. There we go. Got all the dust out. Yeah, that's the new Glenn Pathfinder. So this is Blue Origin. So that means this is Complex 36. Oh, look. They got the SPMTs ready. They're using an SPMT for their transporter. Paper, rocket. They copied your rocket from KSP. Yeah. Oh. See, this is just a mock-up, guys. But it's used for fitment purposes to test how stuff goes together, which is actually pretty freaking cool. Oh, it's so frustrating because people are like, you're not an astronaut. You're only up there for a few minutes. So then I'm like, Alan Shepard's not an astronaut after that flight. Yeah, Meeps, I don't know, man. Don't listen to him, dude. It's just, don't listen to him. You've been there. They haven't. It doesn't even matter what you call yourself, you know? You can call yourself a banana knot, or a mouster-knot, or a catter-knot. Doesn't matter. You've been to space. They haven't. That's their problem, not yours. I would just ignore them every time. Oh, you're not a real astronaut. Okay. Sure. You can keep saying that. Hey, have you crossed the Kármán line? Oh, you haven't. That's right. Oops. Meeps was on a launch. Yeah, Hibbit. On NS-19. He launched on New Shepard, yeah. Streams on Twitch, too. Good dude. Yeah. So that's about that and more about them not knowing anything and using it to invalidate you. Yeah, Meeps. Look, no, I hear you. I mean, I'm not gonna say that, you know, people have, you know, like, oh, I have it so bad, but, you know, I get people all the time. Oh, you're not an engineer. All right, I never claimed to be one. You know what I'm saying? I'm not an engineer, but I play one on Twitch. You know? Yeah, dude, I got you. I get every once in a while. I get hate messages like that. I don't pay it any mind. It's just words. It's just miserable people on the internet, dude. People try to invalidate me all the time. I don't care. That's the difference. I don't give a you know what I'm saying? Who cares? Who cares what they think? Bro, it's just words. Screw them. Screw them. You know? Not this finger. The other finger. You know, like, you know what I'm saying? You've been there, dude. Who cares? Doesn't matter. You've been into space. It's not... Okay, it's not orbit. All right, cool. Yeah, sweet. I guarantee you, half of these people that are giving you crap about this, if they were in your position, they would be saying, "Oh, I went to space. Yeah, I went to space." It would be reversed. But I don't think, Meebs, I don't think you're a piece of trash and would try to be a dick to them. You'd be like, "Oh, that's cool," and that's the difference between you and them. Frick what they think, dude. If people are gonna try to invalidate you with words, you should invalidate their opinion. Done. Invalidate their freaking opinion. Because you know what really grinds people's gears? When their opinion doesn't matter. That's what really grinds people's gears. Like, dude, I have my opinions about NASA, but at the end of the day, it doesn't mean dick. It means nothing. What I think NASA should do is not what they're going to do, because I'm just Mr. Strimmer Man, you know? Frick 'em. It's silly. I'm no NASA man, but a commercial astronaut. I'm pretty confident. Hey, whatever, dude. Like I said, you've been there. They haven't. That's their problem, not yours. You know what I mean? Don't even bother letting them get a rise out of you. You know? I'd just be like, yep. Yeah, you're right, buddy. Keep talking. Oh, EJ, you're not a real astronaut. Okay. Sure. Sweet. Hey, here, let me post this picture of me in space. Can you do that? Oh, you can't do that. I just like, I mean, and you know what? They're probably going to be like, oh, you're such a dick. Like, yeah, all right, whatever. You started it, bruh, you know? A recent TikTok of yours got 800,000 views, so there are so many haters it gets overwhelming. Yeah, Meeps, I'll tell you once. Don't worry about it, dude. Frick them. You've been there. They haven't. They're just jealous. Like, I know that's hard. You could sit here and you could say, "Oh, they're just jealous." I could say it a bajillion times. It's hard to turn that page. I know. I've been in this industry for a long time, dude. But you just, don't pay it no mind. You know, because our brain, you focus on the bad, especially in this industry, you know? You could have 1,000 people saying you're awesome, and then you could have like one person saying you're a piece of trash, and your mind will focus on that one person. So keep it in perspective, dude. How many comments are on that TikTok video? 1,000? 800,000 people watch that video, which means that 99.9% of the people watch that video, and they're like, "Oh, that's cool." You know what I mean? Screw them. You piece of trash. See, drummer hates me. Yeah, Meeps. Screw him. Our mind focuses on the bad automatically, dude. I don't know what it is. Especially when you're in content creation like you and I are. It happens with games. It happens with streaming. It happens with YouTube videos. Like, there's an engineer YouTuber that I watch that I'm a big fan of. He's an actual engineer. His name's William Osmond. He's a really funny channel. He uses engineering to make dumb stuff. It's a great channel. The guy is infinitely smart and a really seems like a really cool dude. I've never met the guy, but you know, he made a video, and then all the armchair engineers came in and said, I've played an engineering game once. You're an idiot. And he started listening to him, and it screwed them all up. And that's a shame, because I like William. I think he's a cool dude. I've never met the guy, but I'm sure we'd get along, you know. Yeah, he's hilarious, you know. Be like, you know, speaking of engineering YouTubers, be like Michael Reeves. Michael Reeves does not give a frick what people think. He does not care. He just does Michael Reeves things. He makes, you know, how many hater comments do you think he got about taking the Boston Dynamics spot robot and making it piss beer into a cup automatically? Dude, he probably got hate for days for that. Do you think he gives a frick? He does not care. Michael does not care. I don't know him either, to be honest, but I know the mindset. He doesn't give a frick. I don't give a frick about these people. Screw them. Because if you listen to these people, you're validating their opinion. Are they right? No, they're wrong. F them. You don't have time for that. You don't have time for that. You got bigger fish to fry, dude. You've been to space. Also, if I could afford it, I would really want a spot Boston Dynamics robot that pisses beer into a cup. His recent video with the fish must have pissed off so many people in economics. Bingo. Exact. Dude, that... He showed it to the investor dude. You remember that? He brought it to like a stock YouTuber, and he's like, "Oh yes, this one is definitely better. This one is not good. These plays are definitely right." Oh my god, that video is so funny, dude. I laughed my tail off for that one, man. So yeah, screw them, man. Screw them. Don't listen to them. Don't focus on the hate comments, man. Like I said, I know that's hard to do. You know, you sit there, because, dude, we're analytical in this day and age. You'll sit there and you're like, why did this person say this? Why did they say that? I'm just trying to really understand what they're saying. Dude, don't even bother. When you ask yourself, man, why would someone say something like that? Just, don't even bother. Don't even bother, dude. Don't even bother. Just keep on doing your thing. You know? Meeps, I'll tell you this. One last thing before we get back into space news. Man, there is... Dude, I've been doing this for a better part of a decade. I've gotten hundreds. I mean, you guys are mostly good to me. I've gotten hundreds of emails saying I'm a piece of trash. I don't know what I'm talking about. Your theories about NASA are stupid. How dare you say bad things about Eric Berger, blah, 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 blah. I've gotten it all. Like, it's just... Yeah, like... It's not that I don't care. It's just, you know, like I don't pay it any mind. And maybe I've been mean in the past, but like it's just like 90% of these people that are sitting here and like criticizing me, right? And actually, not even like they don't understand this side of the equation, right? They don't, because everybody just, you know, it's easy to be in the peanut gallery, man. It's easy to be in the peanut gallery. It's hard to be in the spotlight. And I'm not saying like I'm in the spotlight. I'm some B-list trash Twitch streamer. Like, what do you want? Like, what do you want? I'm not Ninja, you know what I mean? Like, I get it. But 90% of these people, I guarantee you, if they tried to do what we do, they'd fail miserably. So just take that into account, man. Don't take crap from nobody. You're better than that. And I mean that. I mean that. You know what I mean? On the bright side, CNN space reporters saw the TikTok and watched the video doc and are going to highlight it. There you go. There you go, man. Space topics can be really contentious sometimes because on one side you get the nut jobs who think we should cancel everything. Yeah, Kelly, yeah, it is what it is. Why would they write email? Yeah, Reveril, it's some of it's emails, some of it's DMs, messages on Discord or, you know, Twitter, stuff like that. I don't care. Like, I don't pay them any mind. Now, if someone has a valid criticism, I actually will listen to that. Yeah, if someone has a valid criticism of me, I'll hear them out. If someone's like, hey, I really like what you do, but I think you should do this, etc., etc. I don't think you're doing this right. I'll listen to those people. Sure, absolutely. You know, they're like, I like you, but I don't like this direction that the stream is going. I'll listen to that. Absolutely. That's great criticism, you know? Because people aren't going to tell you. You know, if people have valid criticism for your channel or your content creation, it's important to listen, but it's really hard to distinguish who's just there like to hate watch and get a rise out of you and who's actually like legit criticizing. If I have a regular viewer write me a message and they're like, yeah, I didn't really like it when you played this. You know how I think about that? Well, if this person took the time out of their day to watch me, okay? They took time out of their day to watch and they took time out of their day to give me some feedback. That means they care. You know what I mean? That means they give a frick. Because 90% of the people that don't like the content that you're making will just click on another channel. They won't take the time to tell you. That's kind of the hard part about streaming. You never know what people are going to like. I mean, I have a good idea what you guys like and what you don't like at this point because, you know, we have a regular group of guys here, you know. But yeah, you got to sometimes I do listen to the criticism. Absolutely. If it's constructive and it's genuinely coming from a good place, but it's kind of hard to tell that from time to time. But yeah, I'm surprised by how little I've seen people trying to say I'm a gay agenda plan and it's all a hoax to turn you gay by making a pansexual person an astronaut. Meeps, you know what I like about you? You don't make a big deal out of it. It's just, you know, you don't let that define you as a person. It's just part of you, like having a finger. Like, dude, yeah, no one cares. Like, that's cool, man. Like, there are folks out there that really let that define them as a person. And you know what? If they want to do that, that's fine. But yeah, no one's gonna go after you because you don't let it like define you as a person, man. Like, okay, I see people that are like, what's the definition of like somebody that's defined by their sexuality, right? Like, think about like those bros that go to the gym that only talk about getting, you know, fast women all. Hey bro, yeah, I'm gonna go get some fast women, bro. Like, dude, screw those people. Those people are trash. Like, you know, like, and then the vice versa thing of that, it's like, you know, you get the vice versa of that. Like, nobody likes those people, no matter what their orientation is. No one likes those people. They're annoying. You know what I'm saying? To be clear, I have seen that comment, but it's rare. Well, that's good, brother. That's good. You keep doing what you're doing and frick the haters. That's the long story short, you know? That's the long story short. You got this. 800,000 views on TikTok. I don't think there's not many people that can do that. So, good job, man. Good job. Anyway, let's see what else is going on in Tom McCool's Twitter over here. Let's see what we got. Let's see. Beefcake! You know? So EJ just likes gym rats. No, I never said that, 619. I appreciate people that want to take care of themselves. I do. It's just, it really comes down to a moderation thing, you know? Even with rockets, like like if I'm out in normie land out there, I don't talk about rockets. I don't even wear NASA stuff out there. I just wear regular clothes. Because I don't need to wear a NASA shirt all the freaking time. That's weird. Like, and if somebody asks me a question about space, I'm like, you sure? Like, I try not to let space define me as a person, you know what I mean? It's just what I love. But, you know, like, I don't want to be like the old man that's like folding out, this is all my grandkids. Hey, look at all these rockets, you know? Like, that's weird, man. I don't do stuff like that, you know? You just wear your Ford stuff. I actually just wear t-shirts, to be honest. Or a Red Sox hat, but that's about it. By the way, Jay, if you're ever in Washington, hit you up. I could totally get you a tour of blue. Okay? Hell yeah, man, I'm in. Anyway. Normie land. It was a joke. Yeah. Oh, I missed the cap at 619. Sorry. Don't be annoying about what you like. Indeed. So check that out. New Glen Pathfinder, speaking of blue. That's a big stage. 7-meter core diameter, reusable, which is pretty sweet. That's awesome. I mean, this is just a Pathfinder for mock-up stuff, but it's still cool. And also, like the roll-up for Complex 36 right there, and it looks like the pad is getting pretty close to being finished. I also would like to say that if you look at the two lightning towers right here, one of them is a fixed service structure. So it looks like Blue at some point is trying to anticipate some form of crew-capable vehicle. And speaking of that, let's go to the next one here. Let's see, what do we have here? It is heavy? Oh, I bet. Let's see what we got there. That looks like a picture of... Looks like Project Jarvis is out in the wild. Blue Origin is trying to develop a fully reusable second stage. Interesting. Interesting. Yeah, it looks like they got a little can crusher action going on. Gotta climb that tower, yeah, right? Yeah, that's true. Hell yeah. Yeah, see? Oh. Let me check something real quick. We got something over here. Looks like we got something over here. I wish I knew more before the tour because I remember seeing engine assemble. Well, me, you have questions, just hit me up. Like, yeah, no. Yeah, I can teach you what everything is. So you can be like, oh yeah, I saw that. Or, and you know what? Use that to grow for more content creation, dude. It'll work. Trust me on that one. People like rockets. I think I can speak to that one. So That is a prototype test article right there for Project Jarvis, whatever that is. It seems like New Glenn is going to have some type of reusable second stage, which is interesting to say the least. Does ring segment wells look different than Starship? Actually, username, those ones look like early Starship prototypes. Very early Starship prototypes. It looks like they're using a different type of steel, though, which is, yeah, like I said, it's interesting. It looks like Hoppy and Mark 1 too, exactly. And the other thing is that if we go back and look, right, you look at Complex 36 right here. That Project Jarvis, you could see it. It's on the screen right there. See that? Whatever it is. It's right there, and it's clearly been used for some type of tanking test because they have a commodity line going to it. Now, I don't know if that's just for nitrogen. It looks like it might just be for nitrogen, but it may be for LOX as well. This fuel farm right there, that one's methane because see the purge tower? That's how you know it's either methane or hydrogen. They have the flare stack. And then over here, it looks like you have another flare stack right there with this fuel farm. So that, I mean, New Glenn's first stage is going to use natural gas. It uses LNG. And then the second stage is using hydrogen. So I'm going to go ahead and guess that one's for hydrogen and that one's for LNG. I think we've seen that before. I don't remember off the top of my head, but you have double flare stacks here. So one of them's methane and one of them's hydrogen. Thomas is probably linking up the what it is right now. And there's the LOX tank right there. It's interesting to note that Blue Origin built more mounting points for these than they built more mounting points for these than was required, indicating some form of scalability with your fuel farm, which is interesting. Why would you need more hydrogen? Why would you need more oxygen? Yeah, see, the methane one, I think that one's methane. Hydrogen is north, how to rock. LH2 is on top, CH4 is on the bottom. Yeah, okay. Interesting. So that one's got to be, so that one's methane and that one's hydrogen and that one's oxygen. Interesting. That makes sense because it's more hydrogen, because hydrogen can't be stored at a higher density, so you're going to need more tanks. But even the methane right here, methane and liquid oxygen, check that out. Almost as if maybe this, oh, look at the pad right there. It's almost like this pad can maybe hold a bigger rocket. See, scaling the commodities up, you can attach more tanks. Do you think they will go for Starship flaps or wings? I don't know, Hand. I don't know. Yeah, that's what it looked like before. I think they've made some progress here. Former Complex 36A and B. Complex 36 used to be a twin pad complex, and then they combined it. So it's LC11, 36A, and 36B. Blue Origin just took 3 pads and made one big freaking complex with it. Which is kind of cool. The Revision J plans for the pad has all pedestals filled with tanks. Interesting. Interesting. And then, okay, so speaking of Project Jarvis, this is the reason why I wanted to show you guys this. Over here, Blue Origin is building up some tents over here where the LC11 blockhouse was. Complex 11 looked like this, and it was an Atlas pad. And the Atlas pads had, well, that one is used for other things nowadays, but, you know. LZ-14 is still in the most intact configuration because that's where John Glenn launched from, like I was saying. The blockhouse is right here. As the blockhouse in the employee parking lot. You know, up until like Apollo, right? Launch control used to be like 200, 300 feet away from the pad. That's it. With a little sight thing, like October Sky style, you know, like you could look out, okay, it's right there, hit it, you know. And then with the later part of the 60s, you know, NASA switched to Complex 39, so their launch control, their blockhouse is right here, the firing rooms. How far from the launch pad are the fuel tanks? They're pretty far away. This pad is freaking huge, Mad Mage. Yeah, the scale is hard to understand here. So Yeah, see, we're about 600-700 feet away from the pad proper. It's big. Very big. See what I mean? Yeah, it's hard to convey like how big this actually is. A good way to tell, I always look for cars. Everyone knows how big cars are, right? It's pretty easy to spot. Look at the cars parked on the parking lot right there. Look at the cars compared to the pad. They're little specks comparatively to the pad. The Complex 36 is huge now. It's quite big. Yeah. Yeah, freaking huge, man. Which is good. That's cool. You know the other interesting thing, just on a side note, the blockhouse for Complex 36 is still there. See, they kept the Atlas Centaur blockhouse, which is interesting. See, still there. I'm wondering. You know what I'm wondering? If the flame trench for Blue Origin's pad is lined up with the flame trench for 36A. Let me see. So let me just put a point down right there. Let's see. Oh, nope. Not lined up. I was wondering if there's anything, but yeah, no. Yeah, see, that water tower is also huge. This pad complex is about as big as Complex 39, one of the 39 pads. So, like, if you look at 39A and 39B and 36, they're huge. They're all big pads. But anyway, it looks like Tom got some pictures of Jarvis there. So they are building all those tents where the LC-11 blockhouse is, right? And all those tents indicate... Okay, so, like, after a little bit of... Okay, so here's your little bit of story time for the day. I have to give some context here. Jeff Bezos, a little while back, stepped down as the CEO of Amazon, right? He joined the board or whatever. I think he joined the board. And then he flew up into space on the... was it 16? I forget. So, when he landed, when he came back down, he said, like, in a press interview, like, oh, I want to focus on space and stuff. And there was nobody, like, there wasn't really any way to prove it, but I'm pretty sure he started getting more hands-on with Blue, because right after his flight and right after he stepped down, right, 16 had Bezos on it, there you go. And after he stepped down, he, like, we started seeing this stuff like Project Jarvis. We started seeing these tents get put up. You know, we started seeing Blue Origin adopt more of an agile type of framework, which is very interesting. I'm the bad boss. That's right. Yeah, so, you know, if you look at, like, the Slick 36 on Google Earth or on Google Maps or whatever, you can see that they're starting to build a bunch of temporary tents where the LC-11 blockhouse was. And those could be for rapid prototyping along with Project Jarvis. I mean, that Project Jarvis, whatever it is, has been sitting out there for a little while. So, we also saw more lawsuits and graphics. Yeah. Yeah. I really wish they'd stop doing that. But Hell Hydra, everyone does that, you know? Like, it's just because it's Jeff Bezos, everybody notices it. SpaceX did this in 2015. Elon took ULA to court. Oh, yeah. And he won. True story. Because of the EELV. The EELV program. Yeah. That happened. He trashed the ULA CEO, and the CEO did so bad in that congressional hearing or whatever it was that the board fired him and replaced him with Tory Bruno. True story. Yeah, pretty crazy, right? Yep, this stuff happens all the time. It's just standard kind of defense industry stuff. But yeah, it's good to see that Blue is doing something. They're doing work. They're building up stuff. Like, from the NSF video yesterday, we saw them building new facilities at their huge freaking factory at the Cape. That means they're building for something. You don't just build those factories with nothing. Like, we saw them build out Complex 36, right? Saw them build out Complex 36, and... yeah, see, there's a picture of Tom, right? And then Complex 36 has kind of been just sitting there for a little while. It's been just sitting. And now we're starting to see, there's Project Jarvis behind him. Now we're starting to see stuff get made. Like, they're moving the Pathfinder out here, you know. This big HIF that they made right here, the integration facility. They're starting to build stuff out. So, this indicates that they're scaling towards something. And I think, if I had to guess, first of all, it's probably propulsion stuff because of the block buy that Amazon did. They bought 38 Vulcan launches with ULA. 38. It's the biggest purchase of rockets ever. It's bigger than the Apollo program in terms of cost, which is nuts when you think about it. And now they have something to scale to. So I think we're going to see more not rapid prototyping necessarily. We're going to start seeing the gears start turning with all these facilities that Blue has made. But I could be wrong. I don't know. There's TE parts in that HIF. We've seen them come in, yeah. Yep. Hey, Daitor. What's going on? All right. So, Goalie, are you here? Can I show them these pictures? Is that doable? If you want to show all three of these, you can. Okay, cool. Let me just go over here. Launcher keeps showing off their engine tests, guys. Lou also bought a nice Oshkosh. Oh, let me see. Oh, that's cool, man. Dude. Is that what's towing around the new Glen Pathfinder? Oh, that's sick. Look at that thing. What a tank. That is I think that Oshkosh is a 7-ton, right? That's a 7-ton truck. Literally does know how to brand. Oh, yeah. No, yeah. The blue trim looks, that's tight. Also, hang on. Blue Origin Hemet. Yeah. Meeps, like, probably doesn't mean much to you. See this thing? That's one of my favorite trucks. I like heavy duty vehicles that do work. It's kind of a real, 12-year-old boy kind of thing, you know what I'm saying? Like, very stereotypical. But yeah, that's cool. That's like my favorite truck right there. It's an army vehicle called the Highly Expanded Mobility Tactical Truck, or heavy expandable mobility tactical truck. It's called a HEMT for short. Those things are cool. Like big trucks. I'm secretly 15. Don't tell anybody. I mean, look at that thing. That thing's a freaking monster. And it's carrying around New Shepard capsules, which is cool. I think that's neat. Satisfactory update in early June. We watched the video, Linus. Yeah. Those things are cool. You could pull a house down with this thing. Or pull a capsule around. I'll take the capsule around. But yeah, they got that branding game on point, dude. You're so right. Oh, that's for another day. So, I wanted to get into this launcher stuff. Launcher showed some excellent tests. And check this out. Okay, so this is the third camera angle from this test that we saw. The other camera that we watched was over here. Check this out. Headphone users. Capsule equals house. Oh, nice. No, don't worry about it, Vasya. It's all good, man. Look at this. Ready? Headphone users. Again, I'm warning you. Not loud enough. Not loud enough. This next one's going to be louder. Headphone users, again, you've been warned. Hell yeah. they keep showing their tests, and you know what I've noticed about this test that we've watched over the last couple of days? Each one of these camera angles is a different time of day. So that means we don't have different camera angles from one test. That means they've been testing the trash out of this engine over at Stennis, which is cool. That's really cool. And check this out. So here's what Launch is talking about. E2 3D printed engine milestone. We reached our nominal 10 metric tons of thrust. Highest performance, 2.62 oxidizer to fuel ratio, and 100 bar combustion chamber pressure. This chamber is uniquely LOX cooled and 3D printed in copper alloy in a single piece. And look, here's another test. Headphone users again. That's nice. And check this out. Here's what's cool about this. They showed a picture of the throat. Look at that. Dude, okay, so check this out, fellas. That thing is pristine. That's really good. Dude, they really did their engineering homework. It looks like you got a little bit of coking going on up here, but see how the wear seems to be nice and uniform across the whole throat of this nozzle? That's a 3D printed rocket engine that they've been testing the trash out of. Look at that. They posted a picture looking up the business end. You see how even that wear is? That's perfect, man. That is perfect. Oh, that's so cool. I can't believe they showed that. And like, this isn't some like leaked picture either. Launch is just like, yeah, check this out. Chamber's in perfect condition after 40 seconds of flight time. Yeah, see? The wear is nice and even. It might be a little bit uneven like right there, but see? That's perfect, man. Oh, that's so cool. It looks like this coking may have been from shutoff here, from the purge flames. The mixture may have gone fuel rich for a second. See the white residue right there is coking. It's basically the soot, the kind of deposits from using a Carolox motor. It's RP1, yeah. RP1 oxygen-rich stage combustion cycles. So they're channeling an Ergomash here. It works. It's a 3D print, not a 3D printed, but it is 3D printed. It's a smaller RD191 that's been 3D printed. That's the right way to say it. But see how uniform this is and see how intact it is? The scaliness that's here on this texture is supposed to look like that, but it's nice. Dude, there's no deformation here. It's nice and clean, very smooth, uniform texture, and then you got uniform wear on it too. It's perfect. That's really good. That's really good for a first attempt. I'm sorry, EJ. Can we watch those vids again? I didn't have the volume high enough. Yeah, maybe. No engine-rich combustion. Bingo, Vasi. You got to look for the green. Right? I don't see any green here. It's crazy. I can't believe they showed this. That's all 3D printed. Next testing sequence is aiming to have some of these mock diamonds on the full-scale engine. Let me see. Oh, yeah. Here's one of their subscale ones. That was actually the next tweet, wasn't it, Thomas? Here. I caught it. Headphone users again. Headphone users again. I have the volume cranked. Oh, it's so crisp. That is, dude. Okay, all right. I want to remind everyone, that's a kerosene engine. That's a Carolox motor. Do you know how right you have to get the combustion to get the flames to be blue to come out of this thing? Straight up. The launcher prop designer designed Zenit. Yeah, that's right. And then Max Hout is the founder of Mevo, Scary. That's so cool. That's so legit, man. Look at how crisp that is, man. It's so, how do you do that with a Carolox engine? That's impressive, man. That's damn impressive. That's perfect. Oh, look at how, dude. You see how smooth the line is coming out? Oh, dude. I'm like upset. I'm upset with how good that is, you know? Like, I'm upset. It's annoying. Like, that shouldn't happen, but it does. And then, oh. Yeah, scary. No, it's cool. It's cool. I personally, I like Launcher 2, right? When they first came, I'm like, okay. But, the engine test and everything, and then I started reading about their founder, a guy by the name of Max Hout. We talked about him yesterday real quick. He's from the streaming world, dude. Mevo streaming cameras for, like, IRL streaming. Yeah, he founded that. And then he sold it to Logitech, and then he used that money to make a freaking rocket company. 3D printing oxygen-rich stage combustion engines. And then somehow, he got the guy that designed Zenit on the project. This guy's a freaking G, man. This guy's a freaking G. How do you... Dude, what a parry. Like, parried streaming cameras into rockets? That's awesome. Like, I'm not even mad. That's amazing. Good for you. It was when they left Long Island Harbor and came to Cali, then it was game on. Yeah. Unbelievable. Just... Oh, man. Yeah, so fellas, they're going to remove the film cooling from the engine. That's the next thing that they said in the tweet. Next step, we go back in early May with the same chamber and injector with a light rework to remove all film cooling. The goal is to increase chamber of... what's C with the star on it, fellas? Chamber? Combustion efficiency. C star is combustion. The goal is to increase combustion efficiency from 90% in this test to 98%. Can you go into detail why this result is hard to achieve? Sure. And perhaps get our trademark unique blue mock diamonds for Carolox. Okay, why is that hard to achieve? Well, Jackery, you're using kerosene. Kerosene is tough. It's tough. Well, it's not tough to work with. It's very energetic. It's hard to get kerosene to burn efficiently. Okay? Energetic reactions and efficient reactions are not necessarily at odds with each other. You can have efficient energetic reactions. Hydrogen, you could do that with hydrogen, basically. I mean, nuclear blast. Anyway, not very efficient, but, well, kind of is. But anyway, I digress. So, when you're using Carolox with an engine, you're usually they usually just flood the engine with fuel, okay? They flood an engine with fuel, and they get the most energetic reaction out of the engine. And usually that results in a lot of soot. I'll give you an example. So if we look at the Merlin engine right here, the Merlin engine is running extremely fuel rich. So this is Falcon 9's engine right here. It's running extremely fuel rich, and it has an open cycle turbo pump that's dumping fuel rich kerosene. They also run the turbo pump very fuel rich to keep it cool. You don't see a radiator or anything hooked up to this. They do that to keep it nice and cool. Some of them, Mycon, yeah, see? So the engine... So with kerosene engines, you generally don't get a very efficient combustion. You get a very energetic combustion, and usually the result means is that you're throwing unburnt carbon overboard. Now, once again, Jackery, why do they do that? Well, there's two big reasons. One, because with a first stage engine, you generally want to make as much boom as possible. First stage engines don't need to be necessarily efficient. They need to be powerful. TWR versus Delta V, just like Kerbal, same idea. You don't necessarily need an efficient engine for your first stage. You need a powerful engine for your first stage. Because the first stage needs to get the whole rocket out of the atmosphere, and it needs to do it quick. So you trade efficiency for thrust. Now, with what relativity is doing, is taking a page out of the Soviet space program. Now, why? Okay, so the Soviets in the 60s, to build their moon rocket, they didn't want to make like a big engine, like 5 big engines like the Saturn V. they didn't have the tooling to do stuff like that. So what they came up with was a little more of an elegant solution, to be honest with you, because the Saturn V's F1 engines are literally just throw more fuel onto the fire to make the fire bigger. It is about as close as you can get to an SRB in liquid fuel form. They are horribly inefficient, but they make insane amounts of power. So those are the Saturn V engines, right? So they came up with a little bit more of an elegant solution. What was the elegant solution? Well, how can we throw more oxidizer into this equation? Well, they came up with they didn't come up with stage combustion, but stage combustion was a good idea, right? But you want to get more oxidizer in there to burn off all of it. You want to get kerosene to burn efficiently. The problem with doing that is that you need to run a rocket engine at stoichiometric. You need to run it not fuel rich. You need to run equal parts, right? And if you run equal parts, the rocket engine gets insanely hot because if you get a good combustion, a lot of it will be used as force coming out of the bottom of the rocket engine, but some of that combustion will end up being heat. So the more efficient that your combustion happens, the more heat you're going to make. With an RL10 that's using hydrolox, that works to its advantage because the more heat the motor generates, the faster the turbo pumps can spin. But with kerosene, you're usually running fuel rich. 1, to keep the motor cool, 2, to get a more energetic reaction. So oxygen rich stage combustion cycle is what they came up with, the NK15, because it eliminates both of those problems. So the Soviets came up with a really, really heat resistant alloy. I don't know what it is. I mean, Launcher probably has something, something resembling it. Soviets came up with a way to be able to dissipate that heat. And what they did was use the oxidizer, which is cold because you're using liquid oxygen and kerosene, semi-cryogenic, so meaning your oxidizer's liquid oxygen, it's freezing, kerosene is not. They came up with an idea of staging oxygen-rich stage combustion. So they have oxygen going through, cooling the engine with that metal alloy, right? Combined with that metal alloy, it can cool the engine enough, and then they have an oxygen side preburner that takes that gaseous oxygen, mixes it with a little bit of fuel, and runs super oxygen rich into the combustion chamber with additional fuel delivery in the combustion chamber. The idea is that the engines are insanely efficient for kerosene because you're delivering more oxidizer, you're running more at a stoichiometric ratio, and if you run stoichiometric, you don't basically jettison fuel overboard like what some rocket engines do, like basically what you see right here. So, how does that pertain to Mach diamonds? All right. Well, when you're jettisoning unburnt fuel, right? When you're running super fuel rich, your flames aren't as hot, right? Cooling. I mean, look at this Merlin. See the flames coming out? They're yellow. They're not as hot because they run fuel rich to keep the engine cool. See what I'm talking about? And it's not to say that that's a bad rocket engine design. Merlins are genius. Tom Mueller's a freaking legend, the guy that came up with this. The cool thing, the Merlins don't do that, but where they lack in efficiency, they make up for in other things, like being able to throttle them, but that's another story. So going back over to relativity here, that's a kerosene motor. So this is liquid oxygen and kerosene, okay? That motor right there is not running fuel rich. It's not running fuel rich. It's running stoichiometric. It's running equal part. Well, not equal parts. Stoichiometric means you need to deliver like way more oxidizer than you do fuel, right? Which is why the Russians the Soviets came up with that oxygen-rich stage combustion, because they wanted to deliver more oxidizer, right? So the crazy part is that you can, with this, the reason why these flames are so clear is because you have an extremely efficient combustion. The fact that you can see through that flame right there and you can see the corrugated steel on the other side is pretty insane. That is efficiency that not many people have been able to achieve. Only Energomash and then these guys. I thought the Merlin used film cooling. It's open cycle, T-Man. They may film cool parts of the nozzle, but it's open cycle as far as I know. But there's other ways to generate film cooling as well. So, Jackery, long story short, these engines are achieving a combustion efficiency, which is what they're talking about. They're achieving a combustion efficiency where you burn off. You're not leaving much fuel. You're not leaving much fuel on the table, right? You're burning 98% of what you put into that engine. Now that's insanely efficient for a kerosene engine. That's really, really good. And if they can make their big motor do this, well, that's game-changing stuff, because their engines are going to be way more powerful than everybody else's. The clearer the flame... Okay, all right. Just going back to it, fellas. Just another thing. The clearer the flames are on a rocket engine, the more efficient the combustion is. This is why Hydrolox engines, the flames are clear. Methane engines, the flames are like blue, right? Because you have more efficient combustion, you make... if you have a more efficient combustion, right, you make way more heat. And the color of the flame has to do with how hot the flame is, right? Ask anybody that knows anything about firefighting. Color of the flame matters. The fact that they can get blue flames out of a rocket engine and not have it melt itself from the inside out is pretty frigging impressive. Much less with a 3D printed engine. It's pretty cool. Now, don't get me wrong, fellas. I'm not a propulsion engineer, okay? I think I got most of that right, but please, if you heard something you didn't like, or heard something that I said wrong, or you heard something I could explain better, tell me. I'm pretty sure I got that right. If you're burning stoic, right, it's way hotter than burning fuel rich. Fuel rich is you can run cool, right? And when you burn stoic, you don't get any emissions coming out other than the combustion byproducts, which is what you're seeing right there. This motor that they're working on is for the first stage, yeah. But the fact that they're getting clear flames out of this thing is pretty damn impressive. So how is green flamed engines like Raptor? Well, when Raptor shoots out a green flame, it's efficiently burning off the engine inside. Yep. More energetic with a richer mixture. 619, it's just like cars, dude. It's the same thing. So, yeah, it's the same thing, dude. What happens when you spray nitrous into a car? You make a lot more power. But what do you run doing if you spray too much nitrous? Now, why? Why would spraying nitrous in a car make the engine pop? Well, if the engine runs hot enough to melt, yeah, that usually makes something go bad. DSM, nitrous makes it lean, and what does lean do? Lean makes heat. Same thing with a rocket engine. It's all combustion. It's all the same thing. Your piston joins SpaceX. Danger to manifold. Shut up! Hit the other nitrous. So, like I said, the fact that these guys are basically doing the equivalent of just hitting the freaking go button, Paul Walker style, and the engine doesn't explode, it's pretty damn impressive, dude. That's pretty cool. The fact that we can see these mock diamonds here and how clearly defined they are from a kerosene engine is pretty freaking impressive. You almost had me. You never had me. You never had your rocket. Oh! What does lean do? So, Meeps, I don't know if that's a joke or not. I can explain. That's a kerosene engine, Mab. Isn't that? That's what I mean. It's a joke. Okay, cool. I was like, are you actually asking? But it's in quotes, so it's probably not. Sorry, I'm on a roll, man. When I get fired up about rocket engines, my social skills go out the window. This is why I don't talk about space to people in public. It's true. I love lean. This is why I don't talk in public. So hotter is more push. Yes and no, Jackery. If you have a more efficient combustion, you're gonna blow up more stuff inside of the rocket engine. You know, it's mixture. It's a fuel mixture thing. If you have more, if you put more stuff in there and you blow up more stuff in there, it's going to be hotter because the reaction is going to be more efficient. You're burning more. You're literally burning more molecules. You're combusting more things inside of the combustion chamber. And if you're combusting more things, you will make more thrust. But a byproduct of combustion is some of that chemical energy gets made into heat. Actually, a lot of it gets made into heat. So rocket engines need a way to cool themselves, right? But you get a very efficient burn, but you have to keep the thing cool. This is why cars have radiators. Because most of the fuel that you put into your car will end up as heat. Yeah. So, once again, that's why the Russians made that oxygen-rich stage combustion cycle in the 60s, because they needed a motor powerful enough to move that big N1 rocket around. Too bad it didn't work. Kind of sucks, but that was because Sergei died, but that's another story. Not quite. Fuel-rich means that there are no free oxygens to attack the metals or corners. Oxygen-rich means plenty of oxygen atoms around. Okay for ceramic lining, but very bad for metallic ones. Not quite what engine. Wait, what? You're talking. Wait, you're talking about attacking the metal. I'm confused. What? Okay. What's the different cooling mechanisms for rocket engines? Engine Uber, come circle around with me with that one. I'm not sure what the context of what I was saying. I was on a roll there, dude. Have you seen this, EJ? This is a company I used to work for. What's that, Scroat? Wait, you used to work for BWX Technologies? I saw the nuclear proposal that they came out. We shared that for Space News last week, dude. You used to work there? Damn, that's cool. I love expander cycles, though. Expander cycles are cool. I know for the Saturn, they wrap the nozzles in asbestos to prevent it from melting itself. That's from the heat radiating from the rocket engines, Jackery. Yeah, the inside, they had trouble with the outsides of the nozzles melting, not the insides. The insides were film cooled, which is one of the way, that's cool, Scroat. Yeah, that nerve is sick, dude. It looks good. So, what are different ways to cool a rocket engine? Well, film cooling is the most popular. Film cooling is where, well, let's look at the F1 motors and show you.
We have been given the scientific knowledge, the technical ability, and the materials to pursue the exploration of the universe. To ignore these great resources would be a corruption of a God-given ability.
10,
Watch.
9, ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
All right, so let's take a look. So look at when the Saturn V's engines ignite. See all this? See the dark parts of the cloud? That means fuel rich, which is what F1s run. They run extremely fuel rich, right? And then as you know, the engines get up to snuff, they suck all that soot right back down into the flame trench because the engines literally create a vacuum. See, gets sucked right back down. So, see the vacuum? Let's just watch it. Let's just watch it. I'll show you the rest in a second. Oh, engine Uber. Okay, yeah, I got you. Nice. That's nice. at all that soot coming out of those engines. Think those are running? Think those are running stoic? No way. No, 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 no. Oh, it's so freaking cool. I love it. I love it so much. Sure, Zay. Absolutely. All right, so we got past the good stuff. So check this out. So let's turn this down a little bit and let's watch this. So it, like I said, creates a vacuum. You can see the engines are moving the air out of there so fast that it's sucking air down into the flame trench, which is cool. But that's not what we're here for. All right, we want to look at the engine section on the first stage, okay? It's a freedom-rich rocket. You're damn right it is. You're gosh dang right it is. So check this out. Now look at all the ice is falling off the vehicle. It'll get sucked into the flame trench too. All right, let's see the pictures. All right, so check this out. The Saturn V engines are not open cycle. The F1 is a closed cycle film-cooled kerosene engine, okay? It's gas generator. It's about as simple as you can make a rocket engine that's using a turbo pump. It uses liquid fuel. It uses RP1 and liquid oxygen, okay? So there's a gigantic turbo pump over here on each one of these engines. You can see it right there. Now, how do they, Jacker, you were talking about them wrapping the engines in asbestos, which they did do. These engines, yeah, they're wrapped up in asbestos, so the heat that's radiating off from the outsides of these engines don't melt each other. Yeah. That's part of the reason why they ended up wanting shuttle engines on SLS, because the shuttle engines have the hydrogen go through the outside, they go through the channels on the nozzle first. So shuttle engines can be operated in close proximity to each other. RS-68s with an ablative nozzle, you don't want to ablate the outside of the nozzle. That would be bad. That's part of one of the things they had to figure out with Ares 5 is the heat. Clustering engines in real life, guys, is a complicated thing to do because these engines give off so much freaking heat they can melt each other if they're close together. That's something that Kerbal doesn't teach you. So they wrap the outside of the engines in asbestos. Yeah, that's what all this armor plating is. That looks like it looks like they wrapped them in tinfoil. That's asbestos. Now, going back to the gas generator over here. Gas generator, now they still needed to cool the inside of the nozzle. So what they did was, from here to about here, they pumped the liquid oxygen through the channels here on the engine. The liquid oxygen is going through channels on the nozzle in the throat. And then it goes up into the turbo pump and does its thing and combusts out the bottom. But the turbo pump is spinning the fluid impellers for liquid oxygen and kerosene here, and then its exhaust is like that Merlin engine. That's what it looks like. But here's the key. The Merlin is a gas generator, semi-cryogenic, so same propellants, right? Liquid oxygen and kerosene. But the Merlin's open cycle, meaning the turbo pump exhaust gets dumped over the side. With the Saturn V engines, look where the turbo pump exhaust, the turbo pump exhaust goes into a manifold right here. And that manifold, for the nozzle extension, film cools it. Because the gas generator is running fuel rich. And the fuel, like what Enginuber is saying, basically protects the metal from getting melted or eaten by oxygen, etc., etc. So that's a closed cycle engine. See, they took it and they used it for cooling, which is one of the ways that they cool motors. This is called film cooling, and that's why you have this soot layer right here coming out of the F1 engines, because here you could still see there's a nice barrier of fuel, and then it just gets burned off in the engine exhaust because, yeah, spoiler alert, right here it's kind of hot. So I mean, so two things you can extrapolate from this. One, think about how much unburnt soot is coming out of that turbo pump to be able to go into the rocket engine, get introduced to piping hot flames, right? And then have a freaking layer about 2 meters of additional fuel. It takes about 2 meters after coming out of the rocket engine to get burned off by the flames. Think about how fuel rich that thing's running. those turbo pumps on the F1 engines make like 60,000 shaft horsepower or something. It's something ridiculous. So see how much fuel? That's the amount of fuel you need to move to make a rocket engine keep going. It's just incomprehensible amounts of numbers. But they're using film cooling down here. See, they got the film cooling. They're dumping this right here into the nozzle extension to keep the nozzle from melting on the inside. And then on the outside, they just wrapped it in asbestos because asbestos. It's the 60s. Asbestos, baby. How does hydrogen not go to gas when going through the nozzle? How does hydrogen not turn to gas when going through the nozzle? It does, Driados. See, it does. That's the thing. So the Russians came up with oxygen-rich stage combustion cycle using kerosene. That was their thing. That was their kind of big thing with the space race. The Americans, we ended up coming up with fuel-rich stage combustion cycle. Fuel-rich stage combustion cycle favors a fully cryogenic propellants. Part of the reason why, like take Atlas V for instance. Atlas V's first stage has the RD-180 in it, and then it has a Centaur second stage. Because during the Cold War, the U.S. really made a strive to jump ahead using hydrogen as a propellant, liquid hydrogen, which is hard to manage. We know that from the SLS tests, right? And the Russians, the Soviets couldn't figure it out. They said, screw that. That's too complicated for a rocket. You're never going to get that right. So they chose to go down the Karolox tech tree, so to speak, right? So we chose the Hydrolox stuff. And part of that is coming up with a fuel-rich stage combustion cycle. Now, with a fuel-rich stage combustion cycle, you have your hydrogen cooling your nozzle. So this is a shuttle engine now. The hydrogen cools the nozzle, and then it's tapped off. So that liquid hydrogen turns to hydrogen gas and then goes into a pre-burner with liquid oxygen, and you make an extremely hydrogen fuel-rich mixture, and then that goes into the engine, and they hit it with more oxidizer, and it comes out the bottom. That burns extremely efficient, and because you're using hydrogen to cool the nozzle, if it turns to gas, so what? It goes into the pre-burner. It's fine. Pretty smart, huh? Why is the Merlin 1D blowing off the black smoke? It literally means it's already been fired and it's so rich. Well, 619, okay, all right. Back it up a little bit if you're not with me. So the Merlin engine is dumping this overboard. Why? Okay, so if we want to get even more basic, all right? You want to get even more basic here. How does this work? I said that a gas generator was the easiest type of rocket engine that you can make. It's the simplest kind. So what is a gas generator? Well, you have a jet engine right here. You have a jet engine. You have a jet engine that's designed to create shaft horsepower. So it's a turbo shaft, like what you'd see on a helicopter. But it's a turbo shaft running like a 15-to-1 compression ratio with nitrous sprayed into it. No, that's car terms, but they have a jet engine right here, and the jet engine, instead of creating thrust, it is attached to two fluid impellers, so fuel pumps. So you have a turbo shaft attached to two fuel pumps. They're all on the same shaft. There's two of them next to each other. One is for RP1, one is for kerosene. Right? Pretty straightforward stuff. So if you're wondering okay, how if you want 619 you want it in car terms, this would be like taking a turbocharger, right? And taking the compressor housing off and attaching a fuel pump to it instead. Rocket engines need time to spool, just like a turbocharger. But it's a fluid impeller, not a charge impeller. So it's moving liquids, not fuel. So this jet engine over here is attached to two fluid impellers, two fuel pumps, right? And the fuel pumps pump the fuel into the rocket engine. Now, the jet engine still needs to work. So you have a jet engine down here. I mean, keep in mind, turbo pumps are like jet engines on drugs. It is a specially made jet engine. You can't just take a regular jet engine, attach it to the side of the rocket, and have it be fine. It's probably not going to end well. So you have a turbine wheel here, and what do you need to do if you need to keep the rocket, you need to keep the combustion chamber pressure high in here. So what do? They run the turbojet on the turbo pump or the turbo shaft, they run it super freaking fuel rich, like a diesel engine. What happens with the guys that are rolling coal? They're shooting soot out the side because they're running fuel rich to make more power. That is quite literally the same thing, because RP1, the propellant that the Merlin 1D uses, is literally diesel fuel's brother. Yeah, it's diesel fuel's brother. No, Scrotinator, I didn't know that, but that's actually really cool. So, RP1 and kerosene and diesel fuel are all from the same family tree. It's just running super rich. Yep. And they use that extra fuel on the F1 motors. They use the extra fuel and they dump it. They dump it into the rocket engine for cooling. Quite literally exhaust gas recirculation. It's EGR. It's EGR for a rocket engine. That's what that is. It's not EGR, but it's the same idea. They dump the exhaust from the jet engine into the rocket engine to keep it cool. Yeah. I mean, it's to make more efficient combustion with EGR in a car, but that's a little bit different. That's more what the oxygen-rich engine is doing, this thing. But that's another story. Where do they blow the gas into the thrust chamber from the exhaust manifold? Does it have tiny holes in the nozzle, or is there a line that goes into the top of the thrust chamber where it blows it in? Well, Nora, just like a car, rockets have fuel injectors. But since your oxidizer is a liquid, they have oxidizer injectors too. So, like with a car engine, you're taking liquid fuel and gaseous oxidizer, the atmosphere. With an engine, you're taking liquid fuel and liquid oxidizer. Right? Pretty straightforward stuff. So you have what's called an injector plate. It's literally a fuel delivery manifold. The injector plate is, I'll show you. I'll just show you while we're here. It's kind of, if you picture a car has a fuel rail, and then it has the injectors attached to the fuel rail. And you pressurize the fuel rail, and then the solenoids click on and off. And then they spray the fuel in. Now, a rocket engine doesn't need the fuel injectors to shut on and off. So you're going to need a constant fuel delivery system, right? You need a constant fuel delivery system. So you don't need an injector. You don't need a solenoid. It's just a passive system. So picture a pressurized fuel system with just a bunch of holes in it, and it sprays the fuel in constantly. Now here, you know what? I'll show you the F1. I'll show you the Saturn V's engine injector, the one that we just saw. Here it is, right there. There it is. See how you have two holes? Now think about how complicated this thing actually is. And I want to precurse this with some guy machined this by hand. Machined it by hand. No CNC machines. You see how there's pairs? For every pair, one of them is delivering kerosene and the other one is delivering oxidizer. The idea is to shoot the streams of liquid fuel and oxidizer at each other so they chemically combine, they atomize, and then blow up inside of the rocket engine. Is that crazy? Now, I have the odd desire to build a LOX gasoline-powered internal combustion engine. Well, Hellfish, unless you're running extremely fuel-rich, you're gonna blow a head gasket. Oh yeah, very quickly. But yes, yeah. So, you see that right there? That's an injector plate for a rocket engine. This is a Saturn V F1 engine. So that's these things. That's that thing right there. What gets me is how little of a change in diameter there is from chamber to throat. Yeah, for the F1 engines, Hellfish. Yeah. Yeah, that's how much fuel and oxidizer is being delivered in there. That the F1 engines literally don't have a throat. It's just yeet as much fuel at the problem as we possibly freaking can. See, it's funny because the Soviets looked at that and said, wow, that's dumb. Seriously, they looked at the F1 engine and said, nah, we could do better than that. And to be fair, they kind of did. But also, our rocket worked, so whatever. Yeah, see? Just a little, that's the throat right there. Just a little lip. And see how this looks like a bunch of tubes all kind of stacked up together in a circle? It's because it is. Those are the cooling channels. They run the oxidizer through there. The liquid oxygen goes up through here, and then it turns around and goes in here into the injector plate. True story. It's the internet. It's a bunch of tubes. But see, the good part about that Soviet engineering is that we have the Atlas V, which is literally the best of the Soviet space program and the best of the U.S. space program combined into one launch vehicle. So, yeah, it's fine. Can you give me a refresher on what it means to stage the combustion? Okay, fellas. Sure. All right, so stage combustion is basically where you... Okay, all right, check this out. Look. Do you see how the Merlin 1D right here has the exhaust? It has the exhaust from the turbo pump, right? This exhaust is extremely fuel rich. See that right there? Now, that's an open cycle. With closed cycle, that exhaust from the turbo pump goes into the nozzle, okay? For film cooling purposes. Okay. You could use that film cooling at the nozzle. You could use it at the throat. You could even film cool the combustion chamber if you want to. Raptor does that. Raptor film cools all three of those things because yeet. We'll talk more about that later. Now, you could use that for film cooling, Phone Sister, or you could put that through the injector plate. Yeah, that's right. Stage combustion has pre-burners in it. They have pre-burners in it. It's literally two jet engines with their exhaust going to that injector plate. That's what pre-burners are. It's a nice funny word to, make it not seem as crazy as it actually is. So, with the shuttle, the space shuttle, fuel-rich stage combustion cycle, that's the engines, right? They have a hydrogen oxygen jet engine that is with its exhaust dialed in, going right into the injector plate on the RS-25. And then they have a turbo pump on the LOX side that's spraying oxidizer into that hydrogen jet engine's exhaust inside of the combustion chamber. Stage combustion cycle is like having an afterburner for your rocket engine. It makes way more power, but it's also really difficult to take the exhaust from a jet engine and make it go into an injector plate and not melt something. SpaceX knows very well about that. They know all about that. So stage combustion is basically, you have pre-burners, right? So on the shuttle engine, you have a fuel pre-burner. On an RD-180, for instance, you have an oxidizer pre-burner. And these jet engines, depending on whether it's fuel or oxidizer rich, run extremely fuel rich on the fuel side and oxygen rich on the oxidizer side. Up until very recently, no one had tried to do a full flow stage combustion cycle where you have a fuel rich fuel pre-burner and you have an oxidizer rich oxidizer pre-burner, and then have both of those go into a rocket engine. That's what Raptor is. That's why Raptor is so ridiculous. Because it's literally an oxygen-rich jet engine and a fuel-rich jet engine shooting into an injector plate and then blowing up again on top of that. And keep in mind, these pre-burners, right, these jet engines that I'm telling you about for the stage combustion are also moving fuel. Like the shuttle's hydrogen jet engine is also moving fuel to the injector plate combined with this exhaust. It's like a reheat for a rocket engine. It is ridiculous. Crazy, huh? Yeah. So, some engines, like an open cycle gas generator like this, take the exhaust from the gas generator and dump it overboard. Some rocket engines use it for film cooling. Other rocket engines dump it right into the freaking combustion chamber. But you have to be very careful with like a stage combustion cycle, anything, because if you don't get your mixture right at any particular point, it goes too lean in one area, it goes too rich in one area. If it goes too rich, you're If it goes too rich, you're basically going to flood the rocket engine. And if it goes too lean, you're going to melt something. Now, I'll give you an example. SN8. Remember the green flames coming out? Well, guess what? SpaceX had a leak in their methane line on SN8 when it flipped. The methane line popped, right? And because the methane line popped, the mixture got all screwed up inside of the Raptor engine. You don't have fuel, the whole system goes lean. And if the whole system goes lean, the temperature of the rocket engine goes and the rocket engine melts itself, which is why we saw green flames. See what I'm talking about? Cool, huh? It's not, like I said, rocket science is easy to explain. It is hard to do. That's where that phrase, it's not rocket science, comes from. I can teach people rockets. It's not that difficult. It's really, the concepts are pretty straightforward. Getting physics to do that, though, is difficult. That's the hard part. Is there any mechanism for changing fuel and oxidizer mixture throughout the flight based on conditions? I mean, there's, well, Hellfish, you just figured out, you just kind of inadvertently mentioned why throttling rocket engines is tough. So think about this. Think about this, Hellfish. Think about, so Raptor has two pre-burners. So you have a power pack over here and you have a power pack over here, right? They have to spin at certain RPMs, right? Proportionally to each other. Well, you're delivering, with methane, you're delivering more oxidizer than you are fuel. So the oxidizer pump is spinning way faster than the fuel one, right? Because you're delivering, because in order for methane to burn relatively efficiently, you need more oxidizer. That's why the oxidizer tanks on Starship, for instance, are way bigger than the methane tanks. If you go to throttle the engine down and one of these things goes out of, if the proportions get all messed up, the rocket engine will just melt, or it'll just stop working. You have to get the RPMs to be synchronous, but not be synchronous at the same time. It's tough. It's really hard to do. Now, some rocket engines solve that problem, like an RL-10, for instance, by having a gearbox. The hydrogen turbopump drives the oxidizer turbopump with gears, like a Cummins engine. If you look at the front of a Cummins engine, you don't have a timing chain or something. You have your crankshaft gear and a couple of other gears, and then you have your camshaft gear. And then the injector gear as well, but that's another story. Yeah, RL-10s have something like that built into them onto the side. They have they have twin turbo, twin fuel pumps, but the hydrogen one is the expander pump, right? And then that's on a geared mechanism to the oxidizer pump. Yeah, it's crazy. How do you throttle a turbo pump? I don't know. How do you do that? You need some type of pressure regulator in there, 619. Can you imagine what the pressure regulators look like in those damn rocket engines? They have to be able to regulate pressure at like 300 bar. Or no, not even 300 bar. It's higher than that, like 1600 bar. This is why rocket science is difficult, man. Yeah. Think about the pressure regulators, dude, inside of those things and the pre-valves. It is nuts. It's truly ridiculous what those things do. It's like, okay, dude, I don't even understand propulsion engineering completely. But the parts that I know, I'm sitting there going, how are you going to do that? All right. A brake disc on the turbine? I don't know. And is that why also the higher pressure engines can throttle more? I suppose it would be insanely hard to change mixtures in such a way that would be worth anything. Yeah, Hellfish, basically your fuel maps stay at the same mixture from start to finish because, I mean, I suppose you could change it, but changing it is going to screw up a lot of other things, and getting it to change between your oxidizer and fuel proportionately is very, very tough to do. That's really hard. Nah, they use drum brakes. That brake disc would not last very long. Yeah, DSM. It'd be like attaching a brake rotor to a flywheel on an engine and then trying to hit the brakes when the engine's at like 8,000 RPM. All you're going to do is just make a lot more heat. Hey, a feasible use for the MGUHs. Oh, jeez. But yeah, hope you guys enjoyed that that little quick thing into propulsion engineering. It's really cool. It's really freaking cool, actually. It's really interesting stuff. But yeah, the fact that launcher is able to run they're aiming for a 98% combustion efficiency is unreal. So a clutch dump. Yeah, Blueberry, indeed. A single E2 engine is needed to boost our launcher light vehicle to orbit. Higher performance translate into more payload per rocket and lower costs to orbit for the customers. But yeah, I mean, with all that being said, they're running super oxidizer rich, right? And as Enginuber was saying, the oxidizer is coming in here and likes to eat at the metal. The fact that after 40 seconds of firing this rocket engine at 100 bar chamber pressure, that there's really no deformation on the nozzle is unreal. That's really good. That's really well made. That's doing your homework right there. That's why I've been nerding out over launcher lately, because what they're doing with their engines is actually game-changing stuff. I mean, once again, it's not anything particularly like oxygen-rich stage combustion cycle is not new. That's been around for years. The Soviets did it in the 60s. They were the first ones to do it. They invented it. But the fact that they're doing an oxygen-rich stage combustion cycle with a 3D printed compound is unbelievable. Because think about all the heat that this thing has to go through from running so oxidizer-rich. Think about all the heat that goes through that thing. The fact that they're 3D printing it, I mean, if you could try to make this out of PLA, it would melt it instantly. There would be no rocket engine left. The fact that they're using a 3D printing technology to make a metal alloy that can withstand an oxygen-rich stage combustion cycle is pretty cool. That's pretty cutting edge stuff. You're just making me want to build something silly even more. Yeah. 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 3D printed oxygen rich atomic. Isn't that cool? That's, dude, like I said, I wouldn't be gushing over this so much, and I wouldn't have talked about it so much this week if it wasn't for something like this. That's really freaking cool. Make PLA rockets. You can make rocket engines out of PLA, Akabidi. People have done it, actually. I know what you're going to ask. How do they cool it? Well, long story short is they don't. It's an ablative rocket nozzle. Heck, you can use PLA as fuel. I've seen people 3D print solid rocket boosters using PLA as their propellant and their ablator. Yeah. I mean, you're not going to use it again. It's going to melt. It's a solid rocket booster. You're not using it again. Fireworks do that, to be honest with you. Fireworks burn the bottom of the casing off. It doesn't matter because the firework's not going to be reused. I too watch Integza on occasion. That guy is cool, Warlock. I like that channel a lot. He does a good job. Cheap single use, like a firework. Have there been experiments with unconventional injector positions before, or is that why the rotating detonation engine is such a step forward? Oh yeah, there's been all kinds of stuff. So Raptor is using a swirl port injector, or a bunch of swirl port injectors. So like if we're looking at the rocket engine from the side, right? And you're looking at it from the side, and this is the injector plate. You have a pipe for your liquid fuel, and you have a pipe for your oxidizer, and then those nozzles go like this, and they spray into each other, so they atomize right here and go down like that, and then you get the big boom down here, right? That's like what we looked at with the F1 a second ago. That is their radial. It's a radial injector, I think is what it's called. I forget. I must have X'd out of the image. Now, there's a swirl port. There's a swirl port injector, right? Which is basically, if this is the top here, this is the top of the. Say that's the injector plate, right? So the rocket engine goes down here like this, right? And then that's the throat down here. So swirl port injector, keep in mind, this isn't exactly what it looks like, but here, I'll give you the idea. The injector design that I just showed you where they spray into each other, that's called it's an axial injector, excuse me. It's using jet engine terminology. Now, a swirl port is a radial injector. So think about this, Hellfish, right? you have a cup that's on the top, or you could have a bunch of them, right? You have a cup on top of the rocket engine like this, right? And then... And the way your fuel is delivered is like this. And the oxidizer is delivered like that. And they swirl around like a tornado into the combustion chamber. That's a swirl port injector. It's a radial fuel injector. Pretty cool, huh? Like a turbocharger. Same idea. Stuff goes in and then it swirls around and it goes out the side. It's the opposite of that. Fuel and oxidizer go in from the sides and then they go down into the rocket engine. Raptor uses swirl port injectors. Video on the swirlers. I'm new here. What's happening? Hey, Hell. How you doing? Yeah, let's see. So, Copenhagen suborbitals. Thank you, Thomas. I was either going to link this or we were going to go look at Scott's video about it. Here, take a look. Yeah, see? Swirl port injector. That's the best way to atomize the fuel, believe it or not. Basically make it into a giant tornado. Internal combustion engines do swirl port, albeit slightly different. Well, isn't it it's a conic axial injector. Yeah, see? There's an injector piece right there. And then Hellfish, there's another type of radial injector. Here, where's the video, Thomas? Do they show the thing firing in here? No. Here. Probably gonna get put on a list for that. So here's Scott's video. Scott has an excellent video on this, and I'll link it in chat. This is Scott Manley on fuel injectors, or on rocket injectors here. Scott showed it at the end of this video, if I'm remembering right. Yeah, there it is. Right there. Watch. There's your swirl port injector. This is from Copenhagen suborbitals. There's what that guy was just talking about. There it is working. That's what a rocket injector looks like. Literally looks like a shower head. Same idea. Does Scott have non-excellent videos? No. Pretty much everything that Scott does is amazing. Yep. I see. Swirl port injectors. Raptor does something like this. It doesn't look exactly like that, but... Oh, that's cool. Pretty sweet, huh? Swirl port. Yeah. Scott's awesome, Caviar. Yeah. He's taught me a lot, to be honest. I mean, Scott's way smarter than I am, dude. Are the plates always flat? It could be. There's the only bad Scott video is the video he hasn't released yet. So we were talking about the Merlin 1D earlier, Hellfish, so check this out. The Merlin 1D does not have, it has a radial injector, but it's not a swirl port injector, okay? So if we look at a Merlin 1D from the side, right? Here's your nozzle, right? There's your throat, there's your combustion chamber. The axial injector is going to shoot fuel like this. They're going to shoot fuel and oxidizer at each other like that, and then you're just going to make boom out the bottom, like the Saturn engine, like the F1. And then there's the swirl port injector where you have a lot of cups on the top and it swirls in, and then you get a lot of boom coming out the bottom, like Raptor. The Merlin engine uses a pintle injector. A pintle injector is a straight radial, non-swirl injector. So the Merlin engine has something along the lines of a pipe going down all the way in like this. The oxidizer gets sprayed straight down, not at an angle. It gets sprayed straight down, and then the pipe down here has basically a carrot at the end. Similar to like the automated sprinklers that pop up and they shoot out water in a cone. The fuel goes this way. Or it might be the oxidizer, I forget. It shoots out in a cone like that. But because it's shooting out in a cone down here, it mixes and then it combusts and then goes out the bottom. Now, why would this be preferential over anything else? Like, why would you want a pintle injector? It's like I said, it's one big sprinkler head in the engine, and it's shooting the fuel sideways instead of trying to shoot it down. Why would you do that? Well, one, you get really good atomization that way because the fuel is going this way and the oxidizer is going this way, or vice versa. I forget which one it is. They're hitting each other at 90 degrees instead of like a 45 degree or a 60 degree like that. So when they hit each other like that, you get really, really, really good atomization. Now, the second part of that is the fuel is spraying all over the combustion chamber. It's not spraying straight down. Now, why is that a big deal? Because when the fuel is spraying straight down, okay, you're going to fill up the combustion chamber, right? But you're going to fill up the combustion chamber only at with a certain amount of fuel and oxidizer being delivered. What does that mean? Well, that means that a regular axial injection rocket engine, like an F1, for instance, is not very good at throttling. You have 0 and you have 100%. You have off and on, and that's about it, right? Now, the reason why is because if you decided to throttle that engine down somehow, you're going to start to get cavitation inside of the combustion chamber. If you lower the combustion chamber pressure enough, especially if it's a first stage engine, the ambient pressure will come up inside of that engine, and you'll have pockets of low pressure air. You'll have pockets of low pressure inside of the engine. If you get pockets of low pressure inside of the engine, you're going to get non-uniform pressure pushing out on the combustion chamber, and because you have non-uniform pressure pushing on the outsides of the combustion chamber, you get non-uniform heating, explosions. Explosions is what happened, or the engine just flames out. Now, with that radial injector, with the radial injector, the pintle injector, like on the Merlin 1D, what does that mean? Throttleability. You can throttle it because you're spraying the fuel sideways. It's always going to fill up the entire combustion chamber pressure with explosion, and it's always going to push out at a uniform pressure because you're spraying the fuel sideways. It basically, those pockets that would happen, that cavitation inside of the combustion chamber that would happen, doesn't happen with a pintle injector because you're spraying the fuel at where those pockets should be. The pockets usually happen, if you have cavitation, they usually happen right before the throat. Yeah. Pretty crazy, right? That's why they chose that with the Merlin engine. That's why the Merlin engine is a good design. Because Tom Mueller, the propulsion engineer that came up with that worked for SpaceX, he's like the third or fourth SpaceX employee, right? Behind Elon and Hans Koenigsmann and Gwen Shotwell, right? He came up with that idea because throttling a rocket engine is really good for doing things like, landing your first stage. And the funny thing is that the Merlin 1D is not the first of its kind. It has a grandfather. It has a great-grandfather. Anybody know what it is? What other application here would be good where you have to land a stage somewhere in rocket history? Think about it. Yeah, goalie, pretty much. Yeah. The firefighting nozzle. Yeah, you guys know. You guys know the trivia question. The LMDE. The descent module.
Discovery, go at throttle up.
The descent module for the lunar lander. For the LEM during the Apollo program. There it is. The LMDE. Lunar Module Descent Engine. Pintle injector. I don't think I need to explain why, because what the LEM does when it comes back and lands is not that far off from what Falcon 9 does. It's just atmospheric conditions and gravity is a little bit different, but physics doesn't change if you're on the moon versus here. It's just different gravitational perturbations and atmospheric perturbations, but it's the same idea. When it comes to rocketry, it's the same thing. The LMDE, so here, let's bring it full circle now. Why is that related to the LMDE? Well, the LMDE was made by a company called TRW. TRW folded in 2002. The same year that SpaceX got founded. TRW folded, and they had a young propulsion engineer at the time named Tom Mueller. Guess where he went? He went to SpaceX. Yeah. The Merlin 1D is a direct derivative of the Lunar Module Descent Engine. Pretty cool, huh? To bring that full circle. Yep. Hey, 33-month resub. Pretty cool, huh? I thought that was neat. Yep. Yeah, in rocket lineage, the Merlin 1D could trace its roots directly to the LMDE. The LMDE was made by TRW. And TRW was working on pintle-injected rocket engines when they folded. And then Tom just took that technology and just brought it to SpaceX because it's really good for landing first stages, and it worked. SpaceX killed TRW, confirmed. Yeah, okay. Tom Mueller's the one that also loves cars, right? Yeah, he's a car nutcase. I'm noticing a trend here, Apocalypsis. Usually people that like messing with rockets like messing with cars. I mess with fake rockets, but I mess with real cars. Does that help? I mean, it's almost like we all like the same stuff. And the X-34. Yeah, that's right. So that pintle injector makes it so the engine can throttle. It can throttle down. It's called deep throttling. Some rocket engines can maybe get down to 80% throttle with a straight axial fuel injector. Maybe they can get to 90% before they have cavitation. The swirl port injectors are actually probably the best one. With swirl ports, you can throttle all over the place if you want, provided your combustion chamber pressure is high enough. But with the Merlin engine and that pintle injector, you can throttle down to 40%, no problem, which is absurd for a liquid fuel engine. That is a feat of engineering in itself. And that's why, even nowadays, watching Falcon 9 land still blows my mind, because I know what that Merlin engine is doing. It's really, really crazy stuff. You can throttle around Merlin engines like you throttle around stuff in KSP. Think about that for a second. That is insane to do. Remember how we talked about how much those things actually have to move? How much fuel, how much oxidizer, getting the mixture correct, right? Not going lean, not going rich. With all the temperatures and the pressures that are going on, cavitation inside of the combustion chamber, non-uniform heating inside the combustion chamber, with all the film cooling, the open cycle stuff. All that stuff's going on when a Falcon 9 comes down and lands, and the Merlin 1D overcomes a lot of it to be able to land that stupid thing because they can throttle it. They can throttle the engines. It's crazy. It's crazy. It's crazy. Who the frick thought of this? Well, we know. Was the LMDE the first engine able to throttle like that? No, Bagel Buddy, believe it or not. X-15 was one of the first throttleable rocket engines. Yeah. There was a mixture control for the pilot on the X-15. Oh, yeah. 60% bucket, right? Indeed, Rocket Guy. It's damn impressive. That's impressive. It's just like, Rocket Guy, we went on a tangent about propulsion here because a frickin' launcher's running right now they're running a 3D printed oxygen-rich stage combustion cycle engine that's film cooled, and they want to take the film cooling off. They had 40 seconds of firing time on this, and they showed the throat of the rocket engine. Isn't that cool? When you're done with space news, here's some pictures from inside the tunnel. Oh, yes. Oh, Matt, you're spoiling me. Hey, Shepard, what's going on? And yet it has too much thrust on one engine while landing and has to do a hover slam. That's right. RL10 CECE achieved 5. Yeah, expander cycle is by far the most throttleable. What's this? What do you have here, Zay? And think about all that next time you watch a rocket launch. Ooh. Ooh. I really dig the transparency. Dude, me too. I retweeted this whole thread. They're talking about their mixture ratios, combustion chamber pressures, and they showed the business end of their rocket engine, man. That's cool. That's really freaking cool. I love it. That's so cool. Shepherd's Glove just went for 55 grand. Just thought you should know. That's good. So, Zay, is that a Falcon Heavy with an S4B on top of it? And a Universal Stage Adapter and an Apollo CSM. Just vibing in Minecraft if you're interested in playing. Shep, I just played Minecraft for early hours, dude. The business end, that's right. It's confidence that nobody else can do it anytime soon. Oxygen-rich stage combustion is hard to do. Very hard to do. The only thing harder to do than that is full flow. What a Raptor engine does. That is also very difficult. Let's see. So, with that being said, here. With that being said, here, I got another video, some test footage. I think this is Raptor test footage here. It's Raptor. Actually, I'm not sure if it's Raptor 1 or 2. I think that's Raptor 1. But here, we don't need to look at the sound. But look at that engine. Look at how. So, remember, Raptor's full flow. It's the most complicated out of everything. Look at how crisp that flame is. You know how many things you need to go right to get that flame that crisp, that sharp, and you can see through it too. It's pretty clear. You can see the diamonds there. See that marked diamond in there? You can barely see it, but it's there. Look at that. Look at how uniform it is. And that's what I mean about Raptor. That's damn impressive. Like, Launcher is awesome. You know, Launcher's awesome because they're just a bunch of guys that are making rocket engines on a 3D printer. Like, it's a little more complicated than that. I'm not trying to downplay what they do. What they're doing is complicated. That's more complicated. But then again, SpaceX has a little bit more money to throw at this, don't they? But also, that's damn impressive. Would they potentially use super densified locks too? Raptor does use densified locks, yeah. Oh. That's just... I'm sorry. It's so clean. That's unbelievable. I can't believe that flame is that crisp with a methane engine, with a full flow stage combustion cycle methane. It's okay. This is the Raptor 2 video from the presentation. Oh, even better. 300 bar chamber pressure in there, and those turbo pumps. You guys remember I was talking about stage combustion a little while ago? It's like two jet engines shooting into the rocket engine, right? And the rocket engine is the afterburner, so to speak. Now, don't get me wrong. For the people that actually know about full flow, I know it's more complicated than that. They're pre-burners with pre-valves and how the delivery systems work. I understand it's more complicated than that. I'm trying to keep it simple. Those jet engines on Raptor, so to speak, the pre-burners, the pre-burner outlet pressure needs to be higher than the combustion chamber pressure, or else you're going to get backflow in the rocket engine. You don't want backflow. You want the stuff to be going that way. You want gases to be going that way, not that way. Think about the pre-burner outlet pressure going into the rocket engine. It's higher than 300 bar. I'll bet you it's like 1600 or something stupid. I'm making that number up. It's something ridiculous to make sure that you do not have anything going backwards through the rocket engine. It's something absurdly high. And to see that all kind of working together like that and not blowing up is pretty crazy. I need the flow to go like this, not like this. The well-designed engine after many iterations. True that. Would SpaceX ever design a Falcon 9-sized Raptor rocket? I don't think so, Enigma. Just because Starship is Starship with those things, with those engines in them is it's OP. It's freaking like that's you don't need anything else. I mean, with that being said, Enigma, I'll bet you if someone pays them the money to do it and they have a need for it, maybe, sure. SpaceX seems to do, you know, there's Elon's goal of like multi-planetary and stuff, right? But SpaceX seems to be able to alter that plan with minor things here and there to be able to get contracts. So if you pay them, sure they'd do it, you know? Somebody's like, I want you to make me this. I mean, and you had billions of dollars to back up saying that. I'm sure they'd be like, yeah, sure, all right, let's do it. You know, that's the cool thing about SpaceX. They just took their Starship thing, which is designed to go to Mars, and said, hey, we can also make this a lunar lander. And NASA's like, yeah, you can also make that a lunar lander. You should do that for us. And they're like, all right. Yeah, we can do that. Sure, no problem. NASA's like, all right, cool. Here's $2.8 billion. Oh, all right, yeah, we can do that. There were original plans for a Raptor-powered upper stage for Falcon Heavy, but that's in the trash can now. Thomas, can you imagine one Vector in a Falcon Heavy second stage? You're going to need a bigger fuel tank. Where's that picture that Zay sent me? I mean, I'm not going to say that I don't want that. Can you imagine Raptor second stage with a wider with a wider upper stage diameter, like a 5-meter diameter? So like Centaur 5, but with one Vector in it. I mean, the balloon tanks wouldn't work with the balloon tanks, but you get the idea. That would be yes. Let me put it to you like that. Does super densified LOX affect combustion or just storage complications? Well, Bond, just because they're running oxidizer rich or they're running densified liquid oxygen doesn't necessarily mean they're running oxidizer rich. It really depends on your mixture. It depends on how much fuel rich you're running. So when the Merlin engine came around, right? When it came around, like the Merlin 1A, they were running really fuel rich, and they were doing that to make sure the engine didn't grenade itself. And as they iterated more over the Merlin engine, from what I understand, they figured out that you can run densified liquid oxygen. And if you can run densified liquid oxygen, well, you're going to run more on the lean side, or more towards the lean side. Merlins don't run lean. If they ran lean, they'd melt. You run more on the lean side. He said more on. And they went a little bit more lean with the mixture, because the RP1 tanks didn't change, right? They didn't change how much kerosene they put in there, unless you can compress kerosene. I wouldn't do that. They probably adjusted the mixture on the Merlins to take the densified propellants. They densify the propellants for storage though, because the more oxygen you can get in there, the more oxygen you bring up there with you, and if you bring more fuel with more oxygen, you're going to be able to have more delta V, because you're bringing more fuel. What do I always say? An easy way to explain the delta V formula, how rockets go, or how efficient a rocket can, or how far a rocket can travel, I should say, is the more fuel you have on your rocket, the further it'll go. The less rocket you have on your rocket, the better, right? If you have more fuel on your rocket and less rocket on your rocket, it can go further. That's the way I say that. So, densifying that propellant, right? They're not necessarily bringing more fuel, but they probably screwed with the mixture rates on the Merlin engine and added more oxidizer, which will get you way more delta V. I thought they did cool the kerosene though. Obviously, Cantab, they could. Yeah, if they chill down the RP1, they should theoretically be able to get more of it in there. But it's not on the same kind of scale as densified LOX from what I understand. I could be wrong on that one, guys. Once again, I'm not an expert on this, okay? I'm pretty sure I know it, but if I did get something wrong, like I said, let me know. I made a booster stage with a single F1 engine. It turns out just one F1 can throw a lot of mass into space. F1s are about as... Oh, geez. What a cursed image, T-Man. You're not? Yeah, I know. So... That tunnel is going from the LA water treatment plant into the ocean. That's cool, man. Would a Falcon 9 be able to put an Orion into space? You'd need Falcon Heavy to do it if you wanted to get your boosters back. F1s are perfect. F1Bs are perfecter. Yeah. It's correct. RP1 can only be compressed so much in comparison. Rocket guy, yeah, that's what I'm thinking. You don't want to you don't want to compress kerosene too much. Yeah. Yeah, you don't want to compress the kerosene too much. That there's a whole style of engines that literally power this world that rely on that exact thing to make power. A diesel engine sprays some diesel fuel, right? A diesel engine sprays diesel fuel. Diesel engines spray fuel into the combustion chamber with an air mixture, and the piston goes up and compresses it. When the diesel fuel gets compressed, it heats up because of the ideal gas law, right? And when that gas reaches a certain temperature, it auto-combusts the fuel-air mixture. Compressing diesel fuel is not a good idea, especially if you can find some oxidizer around it. And don't worry, frickin' Murphy's Law, it definitely would. You can only compress it so much before stuff starts to get weird. How about compressed hydrogen? Nah, you can't do that, T-Man. You try to compress hydrogen because hydrogen molecules are so tiny, it would be like squeezing a sponge with water in it. That's why hydrogen's such a pain in the butt. Those hydrogen tanks, and that's why SLS is having all these kind of teething problems. And they are teething problems. It's not the design. These are procedure things. That's really important to understand. Except for the broken valve on the ICPS. That's not, but I digress. Storing hydrogen, storing liquid hydrogen in a tank is like having water inside of a sponge, all right? If you want to put water in a sponge, you put it in the water, and then you take it out. Making sure that you control your hydrogen flow correctly would be like taking that sponge out of a bucket of water and making sure that no drops fall from it. Very difficult to do. Very difficult to do. Because hydrogen seeps through everything. Everything. No problem, Sebi. Do what you gotta do. Yeah, diesel and kerosene will turn to jello. Yeah, and the other thing, if they chill down that RP1 too much, it turns to sludge. Bill, you're right. Exactly. It'll literally turn to mud. The funny thing is that there's a type of fuel oil, right? There's a distant relative to diesel fuel called bunker C, heavy fuel oil, and it's literally like molasses. That's the kind of stuff that like container ships use. And it's heating oil if you have an oil-fired heater in your house. That's bunker C. Well, actually, the home fuel oil is not bunker C. It's a little different, but you get the idea. They're all distant relatives to each other. Bunker C is like, yeah, it's molasses. You have to heat it up to get it to work. You have to stage it. Interestingly enough. Yeah, you have bunker C, you have to heat it up, and then it'll turn more liquidy, and then you combust it. Like, that's what container ships use. Fun fact, bunker C is so thick you have to heat it to make it move. See? Yep. It's worse than molasses. Yeah, dude, it is icky. And he says it as I type. Yep. Yeah. Hey, Jensen. What's going on, man? You see the Sox game? Oof, I don't have it on. They did good yesterday, but probably not today. Anyway. Great talk about propulsion, guys. That was fun. I enjoyed the heck out of that. So we got a couple more things here. A little update from Kathy Leaders here, she runs NASA's human exploration operations. So basically, she runs NASA's manned spaceflight program, right? So she tweeted today, "We are now targeting 8:55 p.m. Eastern Time on Sunday, April 24th for the AX-1 undocking from the space station due to high winds at the splashdown site. AX-1 splashdown should be about 1 p.m. on Monday, and at the moment, no impact to Crew 4's Wednesday, April 27th launch date, but still watching the weather closely." One hit combined from both teams through 7. Crazy. So, yeah, weather is preventing the AX-1 crew from going back down. They were originally supposed to be up there for a week. They've been up there for 2. Interestingly enough. He didn't even buy them dinner. What's this? The Cubs. The Cubs beat the Pirates 21-0. I was gonna say it looks like a football score, 21-0. That's a football game. That ain't a baseball game. Jeez. And yeah, any people from Pittsburgh are going, yep. All right. What would high winds do to the capsule? Make it hard to pick up out of the water, T-Man. The AX-1 crew. Oh no! Anyway, yeah, right. Slaughter rule, man. Damn. So yeah, the weather is not cooperating, and it's kind of, you know, delaying NASA's operations a little bit, but that's okay. That's okay. Yeah. Okay, Caviar, did I see this? So the president right now is launching a $6 billion effort to rescue nuclear power plants at risk of closing. Well, that's nice. Also, Bunker C is usually contaminated with rust and sludge and water, so if you're using it in a marine diesel, not a boiler, you have a couple centrifugal separators after the steam heating coil to help keep that crap out of the diesel injectors. Source, one of my patent attorneys who is also a licensed marine engine guy. Interesting, Engine Uber. The Little League 10 run rule is looking pretty nice right now. Yeah, Rocket Guy, right? Do the Axiom crew have spare underwear? Yeah. Yeah, you're fine. I'm sure it's not hurting the crew's feelings needing to stay up there for longer, yeah. Yeah, Caviar. Interesting, huh? I mean, hey, look, there's no secret that they're trying to accelerate us to a more sustainable future, right? Like, that's what they're trying to do. I get it. But what I don't understand, Caviar, is why this is so under the table. It doesn't make any sense. Do they charge extra for an extended stay? I don't think so, Jensen. How annoying and disruptive are the Axiom crew? I'm sure it's not a problem, Sig. You have to stay in space for an extended period. Oh no. Anyway. If an American football game is super one-sided, do you say that's like a sports score? And if so, like what other sport? Can't tell, but low-scoring American football game would be like a baseball game. Like, baseball games usually end up like 5-7, or like 4-6, or like 2-3, or 1-0. You know, like, there's usually single digits. People don't usually score double-digit runs in a baseball game, you know. Football games, well, if you score a point, you get 7. If you score a touchdown, you get 6 points, and if you kick the extra point, you get 1 point. And then if you do a 2-point conversion where you try to score another touchdown on your extra point attempt, you can get 2 points. So you can, with a football game, there's a lot of different combinations of numbers that you could get, because there is ways in American football to score 1 point, 2 point, 3 points, 6 points. And I think that's it. I mean, 7 if, once again, touchdown with an extra point with a kicking attempt. Yeah. And then there's field goals, which is a kicking attempt because you couldn't score a touchdown because you didn't get far enough, which is 3 points. So like I said, you can score 1 point for the extra point after a touchdown, 2 points for a safety, 3 points for an extra point, and then 6 points for scoring a touchdown just in a regular drive. Yeah, football is interesting. The scoring system, now that I'm saying it out loud, is kind of weird though, but yeah. What would you call this? Probably because most people hear nuclear power and think, yeah. Hey, you know what? Look, here's the thing. Oh yeah, I remember that game, Jensen. Yeah. What is that? Yeah. What is that like? Oh, I don't know. Playing Madden on easy mode? I don't know. Caviar, scoring football game keeps the viewers invested in watching. Those are my favorite types of football games, dude. My favorite types of football games are the barn burner games where it's like 3-0. Because that means that means that neither team, that basically was a stalemate. It was a tough game. Those games are fun because if you have something like that, if you have a barn burner like that, it takes a while. And which team cracks first? It's like a war of attrition in sport form. It's cool, man. I think it's really neat. That's why I like football. Football is literally like playing Hearts of Iron. It's a strategy game, masquerading itself as a physical sport, which is hilarious to me. It really is. You have offensive pushes and you have defensive pushes, right? And you know, you have an objective, and sometimes you don't get to the objective, and sometimes you have to go on defense. Sometimes you have to play out. It's literally war in sporting form, like it is. Yeah, not too dissimilar to rugby. Rugby is good. I like rugby too. I just don't watch rugby as much because I didn't grow up with rugby. I grew up with American football. That's what I played. I played American football for 7 years, dude. Do you remember the super rainy Pittsburgh-Cincinnati game a few years ago with so many a punt ended up sticking straight up and down in the mud? Yeah, I remember that. If a game is lopsided, regardless if your favorite team winning or losing, it gets boring. Indeed, Caviar. Yeah. It's like watching Formula One races where Lewis wins the entire time. That's boring. I don't want to watch that. I want to watch Max and Charles duke it out. Duke it out for a victory. And that's what happened at Jeddah. And people could say that was a bad race. I don't give a frick what you say. That was an excellent race. Even the sprint race this morning, I don't give a frick that Charles lost. I don't care. It was a freaking awesome little sprint race. That was fun as hell to watch. What are you talking about? Like, really? I just want to watch a good race. I don't give a frick if my team wins. As I get older, I just enjoy watching sports. I just want to see a good game. You know? Anyway, we'll reel us back into space news. What's a touchback worth? Touchbacks aren't worth points. Touchback means you get the ball. Or no. Yeah. Touchback, you get the ball. Yeah. Sorry. It's not football season. My brain isn't in football mode. See last before moving on. Wait, we're talking sports ball and nuclear theory. They share something in common. A meltdown, otherwise known as 28-3. Ooh. I don't know. Dude, I don't bring that up. I feel bad for bringing that up, Hibbit. I mean, don't get me wrong. It was awesome. But I also feel bad bringing that up. As an Alex Albon fan, I am in constant pain. Yeah. Anyway, yeah, fellas. Like, okay, so Caviar, let's switch it back. Let's go back to science stuff. So nuclear, right? Dude, we should have been, like, okay. I'm usually not one to say, like, oh, the U.S. should have done this. The U.S. should be like this other country. You know who we should be like? We should be like ourselves. That's honestly what I think. We should be like ourselves. Blaze our own freaking trail. Why would we copy other countries, you know? With that being said, there are good ideas from other countries. I think France going full nuclear in the 70s and the 80s was a really good idea. That was cool. That's what we should have done. But people hear nuclear, they say they're bad. But it's cool that, you know, especially in the face of an oil crisis, you know, it's not an oil crisis because oil is scarce. It's an oil crisis because they're trying to make it artificially scarce because carbon emissions, right? That's what's going on here. I'm happy to see, you know, Uncle Sam wanting to do some nuclear stuff other than, you know, the nukes that blow people up, you know? As a Vettel fan, I'm in constant pain. Yeah, that's all right. Mazur, Kerbal started mining on Elu. Nice. Remember this epic play? Yeah. I watched that live. I couldn't believe it. I couldn't believe what I just saw. The butt fumble is the best, dude. So goddamn funny. No, not enough sports. We need to talk about more space, man. No. Anyway, so the butt fumble. Would a space station built like a wagon wheel from the 50s be practical? Depends on what you were trying to do, Kuro. But anyway, Caviar, I'm the first round of awards will prioritize reactors that have already announced plans to close. Honestly, Caviar, it's always so funny to me. We subsidized the oil industry for decades. You know, the reason why Uncle Sam, you might think, oh, that's ridiculous, but the reason why we subsidize the oil industry is because energy. At the end of the day, whoever has the energy literally controls a lot of things, and if you can generate more power than the other guy, you can do more things. You generate more power, you can make more guns, for instance. That's basically what the U.S. did during World War II. We had the resources to be able to grind out aircraft carriers, tanks, guns, jeeps, whatever. Right? Having a strong industrial base keeps your country pretty healthy. And that's not just like for defense. That's just civilization. That's just a war. That's not even a wartime thing. Like, look at when we play cities. Having strong industry really keeps your city going. And I mean, like, look at Epcot. We were able to keep Epcot going with designated industrial sectors and stuff. Smart, right? That's why. If you have energy, you can control the energy. You're good to go. Like, you got that whole civilization thing on lockdown. With that being said, we did that because oil was inexpensive, right? Oil's inexpensive. It's really you just literally drill into the ground. I know it's more complicated than that, please. What I'm saying is that getting nuclear fuel and refining it is more expensive than getting oil and refining it. Getting oil and refining it is a little bit easier. That's why we did it, because it was the easy way to make cheap energy, right? And in terms of, like, let's go to the Cold War, for instance. You need to make more guns than the other guy, so you need more energy, right? And you need to make more nukes than the other guy. So any nuclear stuff, instead of putting it to nuclear plants, you put it to nuclear weapons, right? So, Caviar, I'm good that nowadays, like, if you want to subsidize nukes, that's fine. It's not about oil. Everyone's like, oh, the U.S. is addicted to oil. No, the U.S. isn't addicted to oil. We're addicted to energy. Energy, that's the key, right? That's the point. Even Elon Musk, man, he doesn't give a frick about batteries. It's energy. He just has different ways. He has different theories on how we generate that energy, with wind and with solar, etc., etc. But even Elon says with Tesla, it's not about how you generate the energy. It's about storing the energy and having the energy. You know what I mean? That's the 4670 battery cells that he's talking about. Does that make sense? Y'all got any more of that energy? Everybody likes to make the joke, and I've been hearing this joke for 20 years on the internet. The U.S. is there. Oh, if there was oil on the moon, the U.S. would go. Now, the truth of the matter is that there was energy on the moon, we'd be there like that. If there was a cheaper way to make energy, that's where we'd go. So what sort of game are you going to play later? The one on the computer, 95, The power of love is the biggest energy. Give me 1 second, guys. No, B-Money, I haven't seen it. But yeah, guys, it's an energy thing. So I'm happy that the president wants to do things with nuclear. Caviar, what I'm worried about is that it might be a little too late. You don't just, a nuclear power plant isn't on, off. There's a supply chain thing with that because they need fuel, and that fuel needs to be refined. There's a whole conveyor belt Factorio thing going on. Ask anybody that's played Factorio or Satisfactory with the nukes. You can't just, oh, okay, 6 billion here, turn back on. It's not that simple. I hope it isn't too little, too late. So, hopefully this isn't too little, too late, you know what I mean? I just watched a video about storing heat energy in sand. Heat it up to around 600 C, and it can hold it for months until needed in winter. Once again, heat is energy, Maslam, and it's never been about how we make the energy. It's how we store the energy, believe it or not. Now, the best way to store energy right now is in dinosaur bones that have been liquefied over thousands of or millions of years and kind of show up in the ground. Drill it out of the ground. Drill up dinosaur fossils. That's the best energy storage that scratch that. That's not the best. That's the cheapest. That's the easiest way to do it. Out of all the different ways to generate energy, wind, solar, hydro, nuclear, that's the cheapest way to do it. And it's the easiest way to do it because you can get it fast. Right? So, if we're going to go nuclear, it's not something that's going to happen overnight. It's just like, the people that say, oh, we're going to bring all the factories back to America, which is something that I agree with. We're going to bring all the factories back here. It took 20 years to get us to this point. 30 years to get us to this point. It's going to take 30 years to get it back. The U.S. didn't just build its industrial base like that. All right? It took 30, 40 years to get it to where, well, actually, it took the entire goddamn industrial revolution to get where we were. But yeah, there's plenty of different ways you could store energy as heat. We store it as liquid that you put in your car or truck or whatever. Because liquid is the most stable way, and it's energy on demand. It's on tap. Right? That's why we use it. That's why we have it. But yeah, caviar, that's a good thing. Anyway, I got a couple more things for space news, dudes. Here. These are pictures coming from a buddy of mine. I thought you would appreciate them. Yeah, Savvy, that's my favorite one. Like I said, we don't use oil because it's the best. We use oil because it's cheap. You want to see your energy density, right? This is an XKCD right here that shows it. So how much energy? Energy, if you don't know, is measured in joules. Okay? Joules are a unit of energy. How much energy can something make? That is 1 kilogram, 1 kilogram in megajoules per kilogram. So sugar has 19 megajoules per kilogram. Coal is 24. Fat is 39. That's what we use. That's our fuel right there, believe it or not. Gasoline is 46. This is the one that's the cheapest. That's the cheapest, and it's the most stable. It's the easiest to store out of all of these. Except if it's your mom. Then that's easier to store. Anyway. Uranium is 76 million megajoules per kilogram. Yeah, see? It's not the best way to do it. Oil isn't the best way to do it. Nuclear is, but oil is the cheapest. That makes sense? Your mom got lots of energy. Yep. Your mom got lots of energy. Got him. Lord Power. I need white concrete, loads of it. Go look around. Well, sand and gravel is the most in-demand resource. Savvy, you're going to have to go look for some. It would be cool to see if there was uranium on Uranus. Well, maybe we should go over there and figure it out. Anyway, so yeah, look at some of these pictures here. Check that out. So that's 39A. See? There's the SpaceX water tower. It's 39A. Look at that thing. The orbital launch mount. If you want to bulk, uranium has the energy. I'm telling you, 2020. Nuclear, nuclear could solve all of our energy needs. But I have my own personal theories about nuclear power and stuff. I don't like a centralized power generation system, to be 100% honest. This is EJ being a little... I don't like centralized power. I think, having one entity be able to produce all your electricity is not a good idea. You should have a redundancy. Everybody should have their own redundancy. And the funny thing is, like, Elon agrees with me. Mass decentralized power, solar panels, wind turbines. You can generate your own power and store it. Nowadays people do that with like a diesel generator. I think a decentralized power system is a good idea. So you're not beholden to a power company. Look in California, PG&E. If they can't generate enough power, well, guess what? You don't get power. And it's funny because people in California have Teslas. Teslas were subsidized, right, in California. And now you have an electric car. Unless you have solar panels or something, you can't generate any power for it. You can't go to the charging station.
Discovery, go at throttle up.
See what I mean? I have my theories on centralized power. I'm not sure if it's a good idea. Now, don't get me wrong. That's not to say that California is wrong. Not to say that buying a Tesla is stupid. No, screw those people. Like, I'm not barking up electricity. The electric car tree. I like electric cars. I think they're cool. I have nothing against California. I mean, your gas prices kind of suck, but then again, we're talking about electric cars now, aren't we? Yeah, so like if we were gonna go like full nuclear, we'd need to figure out some kind of compact nuclear reactor. Can you imagine if every house had a compact nuclear reactor? You wouldn't need a power station, and houses wouldn't need to be refueled for years. But also, I can think of several problems as to why every house having a nuclear reactor probably isn't a good idea. My issue with decentralized is that it may make maintenance more expensive. Well, Tony, there's a way to get mass decentralized power right now, and that's everybody having a diesel generator attached to their house. Or a gasoline generator. That's decentralized power generation. That works. This is why we use oil, because it's the easiest. It's the easiest to achieve that. That's why we're so addicted to it. Or one of the reasons. Oil isn't just used for power generation. Oil is used for manufacturing of yes. I want this manufactured. Okay, it's probably going to need oil in some way. Natural gas, propane, I'll tell you what, propane will work really good there, boy. It's a good, clean, burning American propane. That's the best one. Swap out substation for small nukes. Yeah, true that. Mm-hmm. So what about hydrogen plants? What type of hydrogen plants, Riv? Cats on treadmills. That's the real game changer. You want mass decentralized power? Cats on treadmills. I don't really like the idea there's lots of tiny reactors. There's more risk in failure with the amount of them. Yeah, I mean, like I said, that would be the ideal, Sig. It's probably not the best solution. Right now, the best solution for mass decentralized power is you having a diesel generator attached to the back of your house. Which gets us back to the oil problem. We're back to square one. How do we do that? Well, solar panels can do that. But if solar panels are going to do that, solar panels don't generate a lot of power. It's like a trickle charge over time. But if you can find a way to store that power efficiently for long periods of time, and right now we store energy in the form of liquid dinosaur fossils, right? Like I said, if you find a way to store that solar power that's generated over time, you basically win the energy. You win the energy crisis, right? There is a guy. Just saying, there's a guy that's literally trying to solve this problem right now. He excuse my language. He shit posts on Twitter a lot. Yeah, shit posts on Twitter a lot. Electrolysis is sustainable, isn't it? Yeah, more or less, Riv. You could do that, but that's you're using, like, okay, net consumption, like, so hydrogen is more efficient, right, than diesel fuel, right? Hydrogen is more efficient, but you need diesel fuel to make hydrogen, so it ends up being a net push most of the time. Like, I'm sure there's a way to do it right, How would solid state batteries fit into energy storage conversation? I'm not too 100% on how solid state stuff works, nuclear. It really comes down to if you could have a battery that could store electricity in it for like a year, then we're good to go. And like I said, there is a guy that's working on this. I firmly believe, fellas, that Tesla is not an automobile company. They are not an automobile company. Tesla is building cars as an excuse to rapidly prototype and mass produce batteries, better energy storage. That's the problem that Elon's trying to crack. I'm pretty damn sure. Because think about it, why does the electric car suck? Why does the electric car suck? Well, it's not the motor. The motor's great. One of the most efficient ways to make mechanical work is an electric motor. That's why, like, a power drill. Can you imagine if the power drill had a gasoline engine attached to it? I'm pretty sure some guy did that on YouTube, but that's another story. It's the batteries. The batteries are the problem. It's always been the batteries. Every one of Tesla's critics, have been, oh, the batteries. Oh, it doesn't get the range of a gasoline car. Oh, the batteries aren't good enough.
The batteries aren't good enough.
The batteries aren't good enough. But they're working on it. Because if you can figure out a way to store electricity with the same energy density as gasoline, you basically win. You basically win physics.
It is I, Drunk Mo.
It is you, Drunk Mo.
Oh my god. I made mistakes.
You made mistakes?
I made mistakes. I had 3 drinks, chat. I had 3 cocktails. It's not a good idea. Yeah. But the food was really good. She didn't make me walk, by the way. She gave me a ride.
Oh, that's good. Nice, man. That's cool.
She just wanted to screw with you.
You need to hydrate. You need to drink water. Novus says so, and he's smart.
I had a lot of water at the place.
Yeah, that wasn't water. It was wine. It just looks like water.
No, it was water. It came from the water thing.
Wine mo. All right, Riv.
No, this is like gin and bourbon mo. Rummo.
Rummo. Gin and bourbon?
I don't know. I could show you the cocktails and I could point to you the ones I had, but I don't know what was in them. What's the energy density of Drunk Mo? I don't know.
Alcohol has energy in it. You know why? It's flammable. So alcohol does have good energy density. It's just not the best, but it has energy density. Oh yeah. It's not the best out there. I don't know how many megajoules per kilogram energy density alcohol has. Somebody would probably have to look that up, but
I got a schnitzel.
What?
I got a schnitzel.
I don't know what that means.
A schnitzel.
Okay. Yeah, alcohol was used as a rocket propellant in the aggregate rocket 2020. Okay, here's what we're going to do. Remo is going to go and lie down now, and I am going to make sure that she, has everything that she needs in order to lie down. Understand?
Have I told you how much I love you?
See?
Because it's a whole heck of a lot.
Okay, so if you guys will excuse me for a moment, I'll be right back. I need to go make sure that, if and when Remo blows chunks, she doesn't, do it all over the bed or on yourself because, that ends well. Ask Jimi Hendrix.
What?
What? Okay, so if you excuse me, there's going to be a minor intermission here. I will be right back. Okay. All right. I'm back. I'm back, guys. How you doing? What is this? Oh, still talking about energy, I see. Plastic is made of oil. Oil is made of dinosaurs. Plastic dinosaurs are made from real dinosaurs? What? That was quick. Yep. Wine mo is all set. And I told her to holler if she needs me. And then she started going on, oh, I'm so lucky. I'm so lucky. I'm like, what are you talking about? She's like, I'm so lucky. You're good. You take care. I'm like, of course I take care of you. It's my job. And I'm like, you're not the only one that's lucky here. And she goes, well, why? What do you mean? I'm like, you literally let me work on your birthday. And she goes, oh, we're both lucky. I'm like, yeah, there you go. Did you set out a spew bucket? Of course. Popcorn bowl works really well. Yeah, that one's free. Actually, most fossil fuel is made from fossilized plants. Okay. Yep. That's a win-win delivered. Yep. Yep. It's a win-win. Okay. Was there anything else? Actually, it's 9 o'clock. Racing isn't for another 2 hours. What do we want to do? What do we want to do? What to do? ETA on OLM pad here at the Cape. Solo Tarkov. You could watch the thing. Oh, the Boca stuff. Yeah. Oh yeah. So we got Meep stuff and we got Boca stuff. Here, let's jump in the Boca stuff first. Let's see what we got. Is this it? This is what you were looking at, right? And then there's also these fun bonus pictures. You know, just in case you needed some extra bonus pictures. Truckstrom. Don't do that to me. Don't do that to me. Okay. Have you seen this company yet? Okay, what is that? Exploration.space. What is this? Alright, we'll check this and then we'll check the Boca Chica stuff. Actually, you know what? We'll do Boca Chica stuff first. Alright, so. Yeah, okay, let's go over here. So, this is coming from Kevin Randolph here. What is he saying? For WAI Media. Okay, okay, Google, I got you. These are supports for the new building. Oh, Star Factory. Well, that's a cool name. Do you want to see a Skylab but made with Gemini architecture? Wait, are we getting a truck stream? No. No, my, it's like impossible to work on the 59 right now. The garage is full of junk again, but that's another story. Star Factory. Star Factory 1. Yeah. What is this? Starlink V1 on Falcon. V2 Plus on Starship. Basically, all our future products will continue to the word star or link. Okay, Star Factory, Star Base, Starship, Starlink. Got it. Alright, cool. Well, those are the names on the supports there. Those supports are going up at Boca Chica. And then what's RGV looking at? RGV took a picture of an orbital launch mount hold down clamp spotted at the production site. Star Trek, Star Wars. No. He thought they'd get sued. You don't want to do that. What other thing has link in it? I don't know. That is very, very, very big. That's a big. Look at the bushing in there, guys. Unbelievable. That thing has some beef. The interesting thing is, okay, so this RGV picture raises a couple of questions. Doesn't the orbital launch mount already have all its hold down points attached? So why would they need new ones? Damn, boy, thick boy. That's a thick boy. Damn. Star Twitter. Yep. So I wonder why maybe these are structural spares or something. I don't know, but yeah, those, and that one's got a lot of paint coming off. Paint's chipping off. So, yeah, redesign or a second pad. Yeah, maybe a second pad. Because these haven't been used before. The inside of the bushing is rusty. It's not scored. It's just oxidized. It's never been used. This would be all scratched and rusty if this was used. Neura Twitter link. Yep. Yeah, interesting here. Yeah, there's the That's a big Allen key. Redesign the boosters heavier so you need something beefier. They would need 20 of those things, Creeper. If 20 of those things show up, then you know. It's a bushing. There's two different types of metal. At least I think there is. It looks like it's sleeved. See? 619? It might not be a bushing, dude. I don't know. Could be a bearing. Could be just the sleeve. I'm not exactly sure what they would call that. But it's definitely... They got some type of... It's some type of... What's the word? Sacrificial, I guess? I mean, think about the weight that you need to move. Think about the weights that you would need to bend something like this. I mean, look at how thick that damn steel is. That thing probably weighs more than a tank. Like the rolly track thing. Yeah, it looks like it's a replaceable sleeve in case it wears out. They use, so, okay, if you have, in real life mechanics, guys, like Kraken Tech and Kerbal, it doesn't really matter. In real life mechanics, right, you usually use a softer metal or a softer alloy for right here. So if you do get some wear and tear, it eats up this metal and it doesn't eat up the actual structural part of the arm. Cars do this all the time. They do it with like bearings on a motor, for instance. If something goes wrong, it's going to eat the bearing and it's not going to eat the motor. Won't it just crack since it's so massive? Sig, I don't know what it would take to bend something like this. This thing was not bent. This thing was welded together. Probably with a hefty amount of welds. And these parts look to be... Yeah, I don't know. I don't even know. That thing is insanely strong. Dude, I think that could survive like a nuclear blast easily. I mean, it basically does. If you think about what's coming out of the bottom of Super Heavy, it needs to be that strong. Yeah, probably laser cut Space Troll. I mean, yeah, I don't know. I don't think this would be laser cut. Probably water. Water if I had to guess. But I don't know. That's a big chunky piece. Give me two. Well, there's two right there, Kem. Damn. What is this? Edel, that is a hold down point for Super Heavy. It's a hold down point. These pictures, and once again, credit where credit is due, fellas. This picture is taken by RGV Aerial. Laser won't cut that thick. It has to be water. That's what I was thinking, 619. This has to be on a water cutting table. you imagine how long it took to weld that together? Dude. There's clearly a weld right there. Yep. Oh man, that dude. I can't even begin to think how long that freaking took. There are no welds? I don't know, man. It looks like there might be some welding going on there. Either that or this part is cast like this. If it's cast like this, well, shoot. That's even more impressive. Yeah, Duke, if that thing was cast, holy crap. That means it's really heavy. That would be really heavy, but I don't see any casting lines. But then again, they could have painted over them, so who knows? Yeah, Bill. That's what I said, it's cast. Yeah, I don't know, man, maybe. Either way, it's a chonky thing. These 20 of these things, 20 of these hold up super heavy. It has 20 hold down points. That's ridiculous. Unbelievable. That is chonky. Yeah, there's 20 of those things sitting on the OLM. So maybe, I don't know. Why would they have these? Maybe it's a redesigned piece. It could be for the Cape. Who knows? I mean, yeah, RGV has the picture here. If we... Little help for those wondering. Oh, Zach chimed in. Oh, they're just chilling over there. The additive manufacturing expert wife is shouting at you. Oof. Subtractive manufacturing is just as simple, or not as simple. It's just, I don't know if it's just as efficient. I suppose additive is way faster. I mean, subtractive manufacturing is fine. Everybody's like, oh, subtractive manufacturing, what about all the waste? What do you mean waste? It's just it's recyclable. If you're milling aluminum, all the aluminum chunks that come off of it, you just boil them down and make more aluminum. Yeah. Zach with the freaking find right there. Let's see. Heading to the Cape? Why would it, Lamau? Okay. Yeah, there it is. See, these are this part right here. Let's see, is there any difference between this part? That part has a slot piece right there, and then it has 3 bolt holes in it. Let's see. It is different. It is different. Look at that. It's definitely different. Yeah, that's a slightly different design. Because it doesn't have this piece right here. Or at least it doesn't look like it does. I could be wrong. That was shimmed on October 7th, 2021, by the way. This right here is the umbilical for, it's the starter, believe it or not, it's the starter wires, so to speak, for the engines. Yeah. There's 20 of these that stick out of the orbital launch mount on the interior. And they connect into all the outside boosters on Super Heavy. And that's what starts the engines. They use compressed nitrogen to spin the turbopumps to start it. So on the note of recycling, most CNC byproduct isn't recyclable. The coolant contaminates the metal and it makes it too expensive to bother cleaning before trying to melt it down. Well, you send it back, Savvy. They send it back and they refine it. You send it back to the refinery. You don't just reuse it right there. And I suppose that's where additive manufacturing would have its advantages, right? Yeah, that flange right there looks a little rusty. Yeah, I saw that. Oh boy. Anyway, what's the next thing here? Let's see. We democratize space exploration. Okay. Our mission is to make space exploration affordable, available, and open. To realize this, the exploration company develops, manufactures, and operates NIX, a modular and reusable orbital vehicle that can eventually be refueled on orbit. The technical bricks of NIX are built with open interfaces. They are available on a space store to enable space and non-space companies to use them and develop new applications. Interesting, Savvy. Yeah. Nix provides a wide scope of missions ranging from 6 months around the Earth and re-entry to landing on the moon and coming back, or performing a 100-kilometer hop on the moon. Nix can resupply space stations and large space infrastructures. Nix has the potential to carry humans. That's bold, man. So they're building a capsule with a service module. Okay. What's the plan for getting it up there? Just out of curiosity. I'm not being skeptic, I'm just wondering. Nix is a modular, reusable, and in-orbit refuelable orbital vehicle which carries cargo and potentially humans in the long run. Huh. Gotta be bold as a startup. Yeah, that's neat. That's cool. Nice service module. Yeah, okay. I mean, all right. That's a lofty goal. I found this in a thread in our Rocket Lab. Okay. At the Exploration Company, we democratize space exploration, i.e., we make it affordable, available, and open. Our team is driven by competence, impact, and efficiency. We are doers, team players, and problem solvers. We take decisions fast, while keeping always the system in mind. Each of us thrives to deliver full speed and take exceptional care of his or her area of responsibility. We are transparent about risks and obstacles, and we can cooperate to overcome them. All right, let's see what we got. Avionics intern, digital electronics intern, production strategy intern, RAMS engineer intern, avionics systems engineer, cryogenic pump development engineer, electronic design engineer, embedded software engineer, executive assistant. Oh, in Munich. Oh, wunderbar. Look at that. Oh, cool. It's a European company. Oh, and space vehicle thermal engineer in Bordeaux. Wow. Okay. Private uncrewed capsule for the Europeans. That's pretty neat. Cool. That's cool. All right. It's bold. Let's see if they can do it. Like I said, guys, don't sit here and be like, wow, that's dumb. No, don't do that. Trust me. You got to respect anybody that has the balls to throw their hat into the ring. This is not easy stuff to do. It's not easy, and it's not cheap. It takes time. That's an ambitious plan. All right. Wish you the best of luck. And Bordeaux in France. Did you know that in France, when a man is caught poaching ostriches, they shave his head and they make him run backwards through the fields? Once you have seen this, it changes a man. Except Python. Yeah, Foz, I don't know what they're doing. They got stones, but yeah, if you're gonna be dumb, you gotta be tough, I guess. So, I mean, they climbed Mount Everest, you know. Please speak again, Lafont. No. European type CRS money. There is a CRS program that has emerged in Europe, and that's probably the contracts that this is targeting, Bill, if I had to guess. I'm starting a spaceflight company. My first rocket is a refrigerator filled with propane. Okay. More rocket news. What's up, Greg? How you doing, man? How's things? How's things, Greg? Oh boy. Oh no. Oh no. Oh no. Oh no. Oh no. Oh no. 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 Oh no. Day 132 of Cursed Rocket photoshops SLS, but everything is 8.4 meter diameter. Oh no. No, no. It looks like Titan. It looks like Titan 3. God, the SRB power. Better pick of the big orange. Let me see. That's a nice picture. Lavi, she took a very nice picture. That would be an expendable launch pad. The LVSA is a cylinder instead of a cone. Yeah, they I didn't even notice that. It looks like Block 1B, man. That's pretty funny. Cursed Rocket Images is great. That's such a good account. I love that person. That's hilarious. Seriously, though. It looks like Titan 3. Here, look. Look, it looks like Titan. Why is the LES not the same diameter? Yeah, immersion ruined. Go back, the other SLS is better. But. Oh, praise Titan 3E. That would have to be the size of the Pyreos liquid propellant boosters, right? Okay. Alright. Okay, new plan. Guys, I got a new plan. Here's the plan. Rocket Guy, you just gave me an idea. So, you know the nose cones that SpaceX is working on, the pointy nose cones for a new Starship, right? SpaceX clearly has some nose cones. We take, instead of putting those nose cones on Starship, we take those nose cones and we build 2 super heavies and we put them on the sides. Or we put them on the top. We put the nose cones on the top, and then we take an SLS core, right? Take an SLS core, put Starship on top of it, and then we put 2 super heavies with the nose cones on the sides. Yeah. 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 You're welcome. How would you light your RS-25s in the air? No. You just fire 66 Raptor engines and 4 shuttle engines all at once. You good. You good. It'll produce enough thrust. Yeah, see? Trade offer. I receive heaviest lift vehicle, or heaviest launch vehicle ever devised by man. You receive some explosions. Do we have a deal? Titan 3E with Centaur is your favorite rocket. Yep. Hell yeah! Now that, dude, yeah. That would be, that. I don't think the SLS core would be able to take the load of 2 super heavies on the side. I don't think there's much out there that could do that. How deep would the flame trench have to be for those? There would be a slight overpressure event involved with turning everything on.
Going throttle up.
Yep, there would be a slight overpressure event. Yep, not gonna lie to you, could happen. I mean, why not go? But why not go with super heavy at that point? I mean, Herdy, we could just. You don't need the SRBs. We could just put an EUS on top of super heavy, and that would make a very good launch vehicle. Yeah, it'd be pretty good. I mean, Zay, I think you had it right. A super heavy with a Saturn V second stage on top of it, with an EUS on top of that. Ooh. And then you get your first stage back. That would be pretty good. That'd be pretty good. I like this plan. I'm happy to be a part of it. Let's just go with Sea Dragon. Put the SRBs on the sides of the Super Heavy booster. So SRB, Super Heavy, SLS core on both sides. Yeah. It's not sustainable. Yeah, you know what the most sustainable is, T-Man? The one where you shut up. All right. Sustain a bull. Yep. It makes sense. It's science. It's boring. Okay. Oh, jeez. It's 9:20. I gotta wrap it up, man. We gotta wrap it up. We got too busy thinking about how it would do that. We didn't consider why. I have another idea. What if we took Ares 1, okay? Took that 5-segment booster from Ares 1. Hear me out. And we took that and we crossed it with a Saturn 1B first stage. So the Saturn 1B is just a bunch of fuel tanks kind of all clustered together in radial symmetry, if you will. What if we just did that with SRBs? You know, we took like 8 SRBs and just made them into just a big solid rocket core stage. And then we just put the EUS on top of that. It'd work. Yeah. Ares 1. But Ares 1 Saturn B5. Yeah, that'd work. Immensely complicated and high risk. Too many vibrations? You'd be picking up some good vibrations with that. Yeah, it's getting a little late. I don't mean to keep Meeps. If you're still here, dude, I don't mean to keep pushing like watching your the footage that you want to show. I don't mean to keep pushing that, but maybe we could do it next week. It's already 9:30, man. Symmetry is nice until it's not. Yeah, but shh. You just need the vibrations to cancel each other out. Yeah, funny story, Yarg. That's what it does on SLS and the shuttle. Yeah, I have that on first-hand account from one of the guys that designed the external tank. Yeah. I'm serious. That's one of the problems that they were trying to solve with Ares 1 when it got canceled, the vibration problems. With the shuttle, you have 2 SRBs, and those SRBs are connected on a big crossbeam. And that crossbeam makes it basically like a tuning fork, and they cancel each other out. True story. Yeah. It's no issue at all? Alright, Meeps. Thanks for being cool about it. Just so much stuff to cover. It's almost like this stuff is complicated or something, huh? So Ares 1 just needed to be Ares 2. Yeah. Yep. Poopy edit. Let's see what we got. Oh. That, you know what? That's not bad. That's not bad. We'd need a third stage though. Yeah, Thomas, we'd need a third stage. Actually, Yarg, you want to see something funny? Here. NASA threw around a concept a little while. While we're talking about just cursed rockets. Here. I'll just. There was a concept that NASA wanted to. Yeah, here. Just look. You're looking at something funny. Ah, you're talking about me. Wow, you're so clever. Yeah. Yeah. Yeah, there's... Yeah. There's that. Yeah, it's funny, Arg, because Ares 2 became a lot closer, a lot more of a reality than you might think. It was a lot closer to becoming reality than you think it was. Yeah. Yeah, that almost happened, by the way. Just thought I'd let you know. Yeah, Haze. This is Haze Gray? Yeah. Yep. Wouldn't that be Ares 3? Yeah, sure. Close enough. I mean, Yark, technically yes, but also no. Because the center one is air-started. How did that thing not suffer from lateral load? How did it not do this? How did it not bend? How would that not have bent? I don't understand. The strain on the braces. The funny thing is, dude, is that that's no different than... This would have been no different than the dynamic loads that the shuttle had. Honestly, would have been about the same. Because the shuttle engines are just... The shuttle engines, when the thing launches, Yarg, are just making sure that the thing doesn't go this way or go this way. It's just balancing... It's balancing for the fact that there's a shuttle on one side. The SRBs are doing the majority of the work. The SRBs are pulling the external tank and the shuttle up. Crazy, right? Yeah. It would have been no different. Which is strange to me. Is that real? This was a concept, guys. It was a concept that was, what? How did SRBX become a thing? I forget. I think SRBX is... Somebody knows about this more than I do. SRBX is a shuttle-derived launch vehicle concept that was proposed by, I think it was Boeing. Alright, AJ, give me 10 minutes and your prayers will be answered. Yikes. Oh, yeah. I mean, yeah, like I said, the SRBs are towing that external tank up. They really are. So, like, it's pulling the... It's actually pulling the hydrogen tank and it's pushing the LOX tank, technically. Which is, once again, it just speaks volumes as to how insane the shuttle actually is. Like, I mean, the solids are just an elegantly simple solution for what it is, you know. Like, think about how much more complicated the shuttle would end up being if it had like a liquid fuel booster. It would be nuts. It would be insanely complicated. What about SLS? Is it doing the same? Yeah. Oh yeah. Oh yeah. Yeah, the SLS does the same. Yeah. It has a huge crossbar that connects the two forward SRB attachment points. I have a picture of it somewhere. Here, let me find it. Believe it or not, SLS is... Like, here, I'll say this. SLS is probably the worst... the worst shuttle-derived launch vehicle out of all of them, except for literally all the others. Yeah. Yeah. No. SLS is a good rocket. It is. I think it's good. It needs a better upper stage. I've said that a bajillion times. But yeah, it's hard. It's harder than one might think to make a shuttle-derived launch vehicle. To make like taking the shuttle parts and making them into a upgoer 5. That's a lot more difficult than one might think. And part of it is because of the loads. The loads that are involved. You gotta remember, the external tank was engineered to be able to be able to withstand a freaking huge brick being attached to the side and pulling down on it. Right? And then the SRBs are, like I said, they're not so much, lifting with the shuttle engine. I mean, the shuttle engines are giving you some upward thrust, but it's more or less to keep the shuttle on an even keel, so to speak. In terms of center of thrust, center of lift lining up. But shuttle-derived launch vehicles are moving all these loads around. They're moving everything around, which is why, that's one of the reasons why it's hard to make a SDLV. They tried doing this in the 80s. They tried coming up with a shuttle-derived launch vehicle using RS-25s. They tried to come up with Shuttle C. Shuttle C probably actually would have been the best one, but we were that close from getting it. It didn't happen, though. But, yeah, the loads are a lot different. Because, Bram, think about that crossbar. That crossbar in the shuttle is just pushing up the LOX tank, right? But now, with SLS, you're not just pushing up the liquid oxygen tank. So first of all, the liquid oxygen tank is bigger. And then second, on top of that, you have a gigantic upper stage on top of that. And then you have a gigantic service module on top of that. You have a gigantically high-mass capsule on top of that. Think about all the load is different. The tank, the external. That's why they needed to that's why the SLS core stage was different. It had to be different than the external tank. The external tank just used, ironically, the external tank used internal stringers and baffles. It was just flat plate stir welded aluminum. The SLS core, because the loads are all completely different, it has an iso grid, which is more like Atlas V or Vulcan or something. It's iso grid friction stir welded aluminum, which is that's why they had to redo all the dynamic load tests. Crack that hydrogen tank on the test stand because they had to make sure that it could withstand the loads, because once again, you're going to make a shuttle derived launch vehicle. You're going to take shuttle engines and SRBs and make them into a conventional lifter. You're changing literally everything. You're taking all the dry mass off of the side and putting it on the top. That is hard to do. I'm trying to find a picture of that crossbar. It's in here somewhere. Looks like you guys all got pictures of it. Here's one of the SLS test articles, but there it is. It's beefy. It is a beef chunker. 3-stage? Yeah, I like that too. That's good, Thomas. Another view. Yep. It is a beef chunker of a strut. That's the forward attachment points for the SRBs, right there and right there. Look at how thick that sucker is. Saturn derived would have been better. I was waiting for it, Savvy. I was waiting for it. Yeah, that's part of the reason why this is taking so long. That and it's almost like you're designing a shuttle-derived launch vehicle is difficult to begin with, and then, we need you to take this really difficult task and spread it over the next 10 years. Yeah, we've already been over why, but yeah, it's tough, hard to do. I mean, and I'm just talking about the loads. That's just the loads. There's 1,000 other things. You're adding another engine. So the plumbing is different now. You need 2 downcomers instead of 1. The diameter of the downcomer needs to be different because you have 4 engines instead of 3. And because you have 2 of them, the diameters are different than this. So you got to change the downcomer. The downcomer isn't shuttle derived. It's a custom thing that's using shuttle derived mount points. There's a whole plethora of stuff that's changed over the external tank. They're way different. And due in 5 years. Yeah, right. Yeah, exactly. Yeah. Rocket guy, yeah. So why did they shuttle derive and not design new? It sounds like it would have been simpler. Well, Thump, here's... Should have gone to 5 engines. Oh, wait. Okay, so Thump, that's actually a good question. Well, they realized that making a shuttle-derived launch vehicle would be good. Okay, so what you lose in cost because you need to change a bunch of things, you gain with Ares 5. You gain because all the people that worked on the shuttle are there. So if you have a program, you know, you ramp down the shuttle program and you ramp up another program while it's ramping down, all you do is just take that technical personnel, the technical expertise from the shuttle program. Why don't we just take them and move it over here? That's the plus about using a shuttle-derived launch vehicle. All the systems and facilities are pretty much there. You just need to do new testing and development. But once again, handling and integrating an external tank in the VAB and integrating the core stage that's not that far off. They're similar. They're not exactly the same because one has a point at the front and the other one doesn't, right? But stuff like that is simple. The methods for putting together the stack is very similar to the shuttle. So you keep all your technical expertise. That right there, you don't need to hire new people. You don't need to train new people. That right there is where the costs would have gone down instead of up, right? So retaining all your technical expertise from the shuttle program and building shuttle-derived launch vehicles with that workforce that you already have can end up being a lot cheaper. So, okay, if that's the case, why does that, what happened to SLS? Well, they canceled the program, they fired everybody, and then decided a couple of years later that they wanted to build a shuttle-derived launch vehicle. So you had to relearn everything now because you fired your entire employee base. Yeah, see? Annoying, isn't it? That makes sense? MV Megan has left the port and is heading to the AX-1 Atlantic recovery sites. Cool. Yeah, Thomas, I can't actually cover that stuff. I gotta celebrate Remo's birthday tomorrow. I'm not going to. I want to, and sorry, her birthday takes precedent. Shuttle-derived should have been more beneficial. Most of the benefit was negated by abandoning the vision and saving $30 billion. Bingo. All the pluses of building a shuttle-derived launch vehicle, Thump, were thrown out the window when we fired all the shuttle technicians and then 3 years later decided we wanted to build a shuttle-derived launch vehicle again. Yeah. Why do you think I get so annoyed at the $30 billion thing, right? Like, whew, man, was that stupid. Night, Nils. Alright, it's getting late, dudes. We're approaching racing. I might just jump into GTA shenanigans if anybody's around. I don't know if anybody's around. Or we could do some railroading. It's really up to you. But yeah, it was a nice chill day. Flight Sim, I don't have it updated, Harp. I wish. I have that new throttle quadrant that I would like to mess with, but... Here it is. All right, Zay, what did you do? Oh dear. Oh dear. Oh, you know. Your center of pressure might make this a little bit unstable, but other than that, it's very nice. What do you have what do you have for a throttle quadrant? It's a Thrustmaster Boeing edition. The downfall is the shuttle hardware is expensive to operate and manufacture, but then again, on a better timeline of development, things could be better than they are. Bingo. That's super heavy with an S2, and then an EUS on top of that. Jeez. Yeah, that's a chonker. That'd be really nice. Aren't you on Gigabit? Yeah, Yarg, of course. But even, I mean, how fast you want me to download 300 gigs or whatever? By the time I get it all downloaded and figured out, it's going to be time to play GTA anyway. There's a second link for the cargo variant. Oh. That's nice. Those are good. That's funny. Oh, boy. Have you done Hunt the Streamer recently? We did it. We tried to do a Hunt the Streamer 2 weeks ago at Wise, and hackers killed it before we could get anything going. Hackers keep screwing up stuff in GTA, and it's killing my GTA segment. I'm sorry. It's really out of my control. Hackers are gone? What? I don't understand. No problems here. Oh, okay. Yeah, I don't think so. Oh dear. Okay. Yeah, Harp, there you go. No hackers in story mode. Oh boy. Alright. I don't know. Like, there's not really much freaking time here, you know? Like, but actually, a lot of people aren't going to be here for GTA tonight. I might just say, frick it, and go take care of Brimo. I don't know. Yeah, fellas, this is a good day. We got some stuff done in Minecraft, but I might have to dip out of GTA. I'm kind of worried. You know, I want to go make sure she's all right. Load up railroads and see what happens. Is Brimo not feeling well? Yarg, Brimo is feeling very well, but also not feeling well at the same time, if you catch my drift. It was her birthday today, and she let me work on her birthday because, like, tomorrow I got tomorrow off, and you know, celebrate her birthday tomorrow. But you gonna feel it tomorrow? Yeah, I know. We could always play with trains. Hey W, what's going on? A friend recommended you to me, and I'm already loving it. Yeah, okay. B-Dub, yeah, or WV, right on. Thank you. I'm glad you like it. Yeah. Hi, I'm EJ, by the way. I can talk about space for literally hours every day, and I have been for like the last 10 years, because I am a little bit of a dork. V-Dub works? Right on. Right on. But yeah, that's cool. I'm glad you like it. Yeah, no, I love talking. Dude, I like talking to space, theory crafting, teaching about space flight policy, and then obviously we playing Kerbal. But I'm between Kerbal saves right now, just to put it lightly. I'm coming up with new architecture, but yeah. Go take care of Bree. I love the trains. Yeah, me too. Anything new about spin launch? I haven't heard much, Benno. I mean, we could play with the trains if you want.
Discovery.
Oh, you got gifted a sub. Jeez. Thank you, whoever did that. Kind stranger. I appreciate it. But you know that trains takes a lot of time. That's right, Altio. If we don't do GTA tonight, I can work on some stuff tonight then. Yeah. Yeah, fellas, you know what I'm going to do? I might... And this is normally not my style. I might take the rest of the night off just to, go make sure that she's okay, and spend some time with her on her birthday. So, we'll pick up GTA next week. Yeah, sorry about that. Stuff is kind of all up in the air, and I know Pi wasn't gonna be here tonight either because it's his wife's birthday too, believe it or not. So, yeah, Altio, we'll figure it out. Oh my God, EJ took one day off. I didn't even take one day off, Savvy. I only streamed for 9.5 hours today. Tell Drunk Bro happy birthday. Will do, Yark. Thank you very much, buddy. So yeah, okay, fellas. If I'm gonna call it a little early tonight, I will see you guys all on Tuesday. Okay? You got the AX1 docking tomorrow, but because it's Primo's birthday weekend. I mean, the deal was she let me work on Saturday, and she gets the whole birthday weekend. So, I've been banned from covering the AX-1 undocking and landing. I've been banned. It was part of the deal. So, I will see you guys on Tuesday. I hope you have a great rest of your weekend. And yeah, thanks for letting me take some time here. Yeah. So, I don't know. Did I get the shaft end of that deal, Jason? I don't know. We got to build some cool stuff in Minecraft today, you know? Build up brownie points for future endeavors. It's give and take, right? Have a good night and weekend, man. You too, V-Dubs. Hey, it's good to meet you, buddy. I'm glad you like the stream. I do talk, like, Space talks about this pretty much every day for about 4 hours. And then also, I play 4 hours of games before and usually 4 hours on the other side. I usually stream about 12 hours a day. So if you pop back in, first of all, thank you. I appreciate it. And yeah, you'll see plenty of me. I'm always around. Except on Sundays and Mondays and now Saturday night. So, all right. I'll see you guys tomorrow. Hey, let's try to pay it forward, see if we can raid somebody, okay? And actually go in there and say raid. Just hey raid, and then you can leave right after that. I don't like raiding people with like 300, like a 300-person raid and one person says hi. Go in there and make sure you pay it forward. Roger's playing some Tarkov. We'll go see what he's up to. I want to watch Tarkov. Go see what he's up to. Give him a raid. Say hi to him. Because he's totally not secretly lonely. No. Go say hi to him. Go show him we know how to raid for a change. I don't usually do that, but go raid him, and I'll talk to you guys on Tuesday. Thank you very much. I do appreciate it. Everybody that bits it, subs, and supports the stream. Thank you very much.